Good morning. We just touched down about 1,500 meters here for this dive stream. So welcome to dive stream 952. Today we're going to be doing a lot of heat flow probing. So we had the map up earlier for you. But basically we've got 7 waypoints. We're going to be scooting along. And while we're doing that, we're going to be setting down, doing the heat flow. So you know the story. We're gonna sit in one spot for a while, a little bit of opportunity to zoom in real close on the ground around us. We are still doing work on a project, so there might be opportunistic filming for that, although I don't believe we're doing a lot of work in mission control today for that. So we're gonna have the mics up for most of the dive today. So I'll be bringing up the rest of mission control mics here, and we'll see what we see.
It's a nice view for the heat flow.
Yeah.
Okay. Look at your stuff.
When you said what, a sleep pad?
Come on, do this stuff.
So it looks like.
I will. Huh?
Alex,
We're gonna do the
is it
excavator
possible
first.
to have,
Yeah.
see that screen with the coordinates on it?
And then when we
The
get a
bottom
chance to
right.
check the
Yeah,
channel,
that one.
This
how
guy?
it's
Yeah.
the-
Can I have that right here?
Yeah.
Turn on power left.
And then can I also have the overlay on this one? Like the temperature?
I'm on in an hour
Ah,
now.
okay.
Okay.
To turn it on.
No, that's to me.
Oh, that was.
It goes after.
Super soft.
Yeah.
Sweet.
So I'm just calibrating it now, so I'll let you
Just
know
take
when I'm ready.
Okay. That's good.
Jenny or Charlotte, do you remember if we have one of those heat
Yeah.
pans?
It looks good to me.
Charlotte, you're the photographer. What do you think?
It looks
Okay.
familiar to me.
Okay, pretty sure. So that's stock of whatever. Turn down your bird so we don't get from.
Okay, so I'm recording, so anytime we're ready to go, like he can do the insertion, then it's just, it goes in at an even rate until the whole probe is in.
Okay. You ready?
Yeah.
I got the best friend.
Oh.
Just waiting for you to see.
It's getting better.
Yeah, until it clears, but.
Do we want this to be reversed?
What's that?
We want these to be reversed? The flow, the heat.
No.
We don't care. Okay.
We should see it like be sort of colder here and then increase as we approach the mud volcano.
Okay.
Yeah.
If there's deeply
See if it
seated.
reduces here so you know, put it on 27 and keep it cool.
Oh, yeah. That's like, it's, the word volcano it gets people very excited. Like, no, it's in mud.
Yeah, perfect.
Yeah, these two.
Can you grab my power cords? I need my computer here.
Yep. It's at the desk, right?
Yeah. It says, "Hi, my name is Rob" on it.
What?
It says, "Hi, my name is Rob" on it.
Just in case
Yeah.
you didn't know which one. Okay, good.
It's kind of weird.
Wow.
So those spikes.
I know where that's from.
Mostly that would just be
And are we doing one measurement? Or two?
So basically one at every station.
Just one at every at
Yeah.
every waypoint. Yeah.
Thanks. No, it was my name tag from a conference, and I was like, wow,
Sure.
whatever, I'll just stick it on here.
Nice seafan to look at. Yeah, I think we have like seen it before. Yeah, shrimp. An amphipoid. Oh, it's a reflection.
There was a little spike on 1 and 9. It's kind of weird. It seems fine though. Like it was just
Like static.
only for 3 readings though. 3 seconds.
Although it was disconnected and reconnected.
Yeah.
Hopefully that doesn't mean anything.
Yeah, I showed it like earlier. Oh, you mean like that? No. That's not ours.
I know, I guess that's to withstand the pressure.
Once it does.
Oh. Yeah. Very cool.
it's always reversed when we start. So, like if they click on the manual, it's auto and vice versa. Yeah.
4 minutes. Okay. 4 minutes. Yeah, and then studying deep sea. Pretty much. That's my next thing. I mean, I didn't really post this, but yeah, diving books. Well, it's turn.
Neil, will the bus go to tilt down a bit?
Turn around.
Yeah, so again, we've got 7 waypoints this dive, and at each of these 7 waypoints, we're going to be doing a heat flow probe. So right now, the heat flow probe is all the way down, and we're just waiting for all the data to come in on that.
Oh, we're good?
Yeah.
Perfect.
Oh, there we go.
Move it up.
Yeah.
So now we'll bring the heat flow probe back up.
How's my light now?
And then we'll start our move to the next waypoint.
Oh, swing in the car. Yeah, they do a few different things, but they want to be exactly so they know exactly what.
Are we sampling this?
No, no, no. Yeah.
We're going to pack away Excalibur here, which is just a inert probe that we use to sort of confirm the softness and depth of the soft sediment before we try to put the heat flow probe in, since that's pretty delicate actually.
I think what we can do is move forward, looking around for like about 50 meters, and then we can do a transect. Or did you want to run the transect one time? Decide if we can do this.
It's only 400.
Yeah.
Okay, so we're gonna make our way
And then I had I was like 50, 300 transects.
a little bit, just exploring, and then it sounds like we're gonna do a video transect after that, which, as you know, is all scoot, no shoot. So we just kind of make our way over the bottom, lasers on, steady speed, steady altitude, and steady camera. So even if we see something cool, we can't really zoom in on it.
So when we start the transect, we just flash the light.
Okay.
Just and then every 100 meters, just flash the light.
Let me know when
again.
you got 1 meter. You're ready. Ready? Okay, flashing lights.
All right, so we're
thank
going
you.
to start the transects now then.
Charlotte.
So we're just flashing the light so that if the scientists go back through this footage, even without the audio, there's sort of a way to differentiate one transect to the next.
Tilt up a little more, what do you say?
For this one, can tilt down a bit more. Perfect. Perfect. Yeah.
We're Jordy. Hey Rafa, we're starting our transect to the next waypoint. Updated your waypoint as well. Please feel free to move ahead. Okay.
All right.
So during this
Now that we're
transect, we have the lasers on. You can see the two green dots there in the middle of your screen. For anyone that's not watched before, those green dots are 10 centimeters apart. So it gives the scientists sort of a scale bar. And as we're flying this transect, they can use that scale bar to sort of measure things on the screen. So far, we've seen a couple of the Formosoma sea urchins. Those are the ones with the weird little sacs on the top of them.
How to use the cruise button. just correct it. Probably take off cruise and just move ahead a little faster to 0.2. Well, what speed do you want? 0.2,
Yeah,
0.3?
0.2 is good.
0.2. So just give it a little more ahead.
Oh.
Right. So 0.2, maintain. Put it in the cruise and
Well, I know what that is on the left. I know we can't see, but
you want to see it?
yeah. We're gonna have to keep going. Because if we veer every time we see something cool, then it becomes biased to transact.
You know, if there's something really cool that you never seen before.
True. Is this fine, or do we want it more?
That's
Yeah.
fine.
Okay.
So overall, we're looking at a 12-hour dive.
A lot of depressions and sediment.
And again, we're looking for bubbles. So this area is relatively flat, but it does have a couple mounds on it that are notable. So on waypoint 3, we're actually going to be on top of a small mound, and then waypoint 7, actually waypoint 5, 6, and 7 all sort of climb up a larger mound here, with 7 being sort of at the peak of it. And we do believe that we detected some seep activity on the northwest flank of the large mound, which is where we'll be climbing up the side of it. So just keeping an eye out for any signs of seeps, maybe even some bubbles, which would be great. But sort of looking for those high density communities that we've been seeing with the mussels and the tube worms, bacterial mats, the shrimp, and little eel pouts, which have been very cute.
Wow. It's the same thing we saw before when we can't bear.
Yeah. This is my people.
What is it? Is it a massive sea cucumber? Oh, is that the massive one we were seeing?
Yeah.
It's huge.
Have you guys sampled this urchin already?
Yeah. Well, I believe. Yeah, I believe so.
Yeah.
We've seen it quite a lot, depending on
Yeah,
the
we
site.
have.
So I think we would have got more. Ooh. Starting to look interesting. Starting to see some bacterial mats, I think. Potentially. And these are bacterial mats, right? Yep. Good science.
Yeah.
Yeah. The like green, white. Did we reach 100 meters?
Probably.
Soon? Oh, well, when we do, we just flash your lights again. Whenever that is.
Yeah, that was about 100 meters.
Yeah, you can flash it all. Whoa.
So every 100 meters you want?
Yeah.
Okay.
I know, I often forget that it's pitch black for them. Because we're seeing it with light, but they don't see it.
Yeah. Yeah. Alright. Great.
We're gonna try.
So when you reach here, that's 200, so I'll be turning the lights off. No, I'll be 200.
So for anyone now tuning in, we are currently on dive 952 aboard Falco 2, and we are currently exploring two mounds that we saw when we mapped, but which have not been visually confirmed. So we started on the flat plain and we're making our way over to a smaller mound. And then after we cross over the smaller mound, we're making our way to a much larger mound. We're looking for any signs of seepage, of bubbles, because the mapping did show signs of bubbling, which means there could be seeps around.
Everything here is free.
And we believe that these mounds could potentially be mud volcanoes.
Making me learn a lot about design.
But again, we can't be certain until we see it for sure. And right now we're just conducting a transect on our way to the mound.
Like future and free.
And we are at about just over 1,500 meters, about 1,506 meters maybe.
What would I say, like, if you want to make this you wouldn't.
And we've currently been seeing some shrimp, sea pens,
So I would
urchins. We saw some benthic ctenophores.
draw this layout.
We saw a siphonophore on the way down, right before we reached bottom.
You choose like the draw line. So you choose this plane.
Yeah.
I want to draw. I want to line it. Line of it is what I
And we're about halfway through the first transect. And then today, every time we reach a waypoint, and we have about 7 listed, we're gonna do a heat flow measurement. That's one of our top priorities today. You can see a fish. It looks like a halo sole.
You get the profile of the so you measure all your things. And you draw it based not on the origin. There's a signal to that circle. You figure out what radius that is or back to another radius there. So you draw the outline. Once you have like the dimension, right? Then you extrude. And that will make it into like a solid object. And then you can then, once you extrude it and you have like the shape and everything, then you don't want to come on display now. First on display, and then come on display, and I do these grooves and so you draw it, you now draw lines, and then you extrude again. When you extrude it, you can choose the cut. So you cut outside any material. So just if you ever did a proper cut, that might be easy work, but that was 20 years ago.
Yeah.
So I never practiced it after. So it will come back to you on how to like put up the line, do a mirror. Stuff like that. It's growing up. I was shy when I first came, like 2 years ago.
That's what we wanted to see. It's the type of thing you have to be more on, and we have the flexibility.
Just choose at least the front. Just choose like
Can.
or a cylinder. That buffer right there. So you have to get the up. I gotta go close back and measure to the unit. Point to the 5 and 1 to get all the things. Put it in. And yeah, that's right too. So first you would this is your order.
Yeah.
So first you would make the buffer again cut the buffer
Yes.
out and to take a thickness and everything. So you do the outer, draw the outer layer, right? And then you'll do offset, right? So if you have the outer shape, you can then offset however thick this is not
Let's
accurate.
make a solid.
To make another thing to
Yes.
the thing, and then you will have
Two more offsets.
yeah. So then you'll have the two entire what do you call it? Thickness of the bottle, and then with your midpoint here,
Yeah.
you would then extrude or rotate around,
Yeah.
and that will build the whole bottle around.
Okay.
So you rotate 180 or 360 whatever, and then the bottle will be. But you already have the wall. Because remember you're drawing.
Not sure when it turned on, but it is on, I assume.
And then when you rotate around, extrude rotate, it'll create the bottle.
Show me that.
Yeah.
Let's make a model. Yeah, one of these. With the wood.
Yeah.
Cool.
Again, the line will be here.
No, but that's.
The hardest thing is like getting it and figuring out how to do it actually.
faster.
No, it is, yeah.
There's no ticket ever coming up.
Yeah, we passed a few. He's such a big boy.
Look at that.
Yeah.
The bit.
Oh, I didn't, because watching, the noticing outside,
Oh, I
it seems
see.
to be big, so I wasn't
I
sure.
see, yeah. The worm. We're still at one. Now we're almost
Have we
200.
sampled one of these
Yeah.
big ones already?
Oh,
From one and 200 from
Have we sampled one of these big ones already?
Yes, we did. I
Yeah.
think so. Yeah, this community seems very similar to one of the other communities we've been at.
Interesting. That's what we're about.
Star. Oh, she's dancing.
Okay, going for lights.
Thank you. We're 200 meters into the 300-meter transect.
Okay.
Particle was.
Right.
We can do some cabin cleaning.
Yeah.
All right, I'm gonna hand over to Rachel while the pilots hand over. They're about to go quiet to like.
Okay, when you reach this 100 meters
No,
here,
that's what
no
they
stopping.
do.
Wait.
Wake them up.
No zooming in.
Yeah.
Transect.
Roger.
Right, when you reach,
Roger.
when you reach this mark right here, flash your lights, right?
Copy. We just started.
We did a temporal at the cursory point. I think you're gonna do another one. Next week. They say it's stopped. So we don't.
Okay, we're not doing a transect now?
We are.
We are, okay. Okay. 100
300
meters?
Left
300.
is the total.
Okay, got it.
Yeah.
So it looks like we have 100 meters left.
What? No, sights.
And then we're gonna head to the second waypoint at whatever speed we desire to get our second heat, which I know is very exciting.
That one, the one that's coming up right there, that's our
Yeah,
next heat flow.
that's
Okay.
next heat flow. And that's the end of the transect.
0.2 was the speed here.
What speed's the ship going?
They were maximum speed at 0.2.
Are you tired from yesterday?
No, not really.
Yep.
Did you use all of your dad jokes yesterday?
No, that's a never ending well.
Okay, that's what I figured.
Thanks for checking.
Yeah, I don't want you to be feeling low on those at any time. Hey, Clint,
Yo,
do you know how to put the little, Fleeter mouse thing on the corner? For the, yeah, just for the people at home to see what we're,
yeah.
yeah, if it's, don't worry about it if it's a pain. I'm just
No,
trying.
no, no. So you want it on the YouTube, is it?
Yeah, just so they can see what we're,
Yeah.
what we,
Huh?
what we're up to.
There you go.
Cool. Thank you.
It's huge. Yeah, it doesn't fit in the jaws. It doesn't fit in the.
Hello, this is Rachel Lauer from the University of Calgary. I am a geophysicist and a hydrogeologist, and today the start of the dive is conducting heat flow measurements on both sides and on top of what we think is a small mud volcano. Overnight, we did some mapping, bathymetry mapping, and identified a lot of features at the seafloor that were previously identified in published papers, but the data from the bathymetry was never shared. So some of this is repeating what has been done previously, but never made public. In those swaths that we collected in our transit from our last site to here, we identified a bunch of structures that appear to be marine mud volcanoes. And before you get terribly excited, these are not the volcanoes when you think about Hawaii and places like that. Instead of molten rock flowing out or exploding out of the top of these things, there is mud that is sort of spewing out at the surface, and over time can create a structure that looks very similar to a volcano. And just like a volcano, a lava volcano, the structure that it takes on really depends on the viscosity of the fluid that is, or the, lava, or in this case, mud that is coming out. So you can get a fairly flat looking mud eruption that doesn't actually form this little mound if it's really low viscosity, so very liquidy. But if it's thicker and more viscous, you can get these mounds that form over periods of multiple eruptions and deposition. And what's actually coming out of them? Oh, this is a weird looking one. Sea cucumber, white. What's actually coming out of them is really like a slurry of water, gases, primarily methane gas, rather than the molten rock that you associate with most volcanoes. And these are where this part of the Trinidad and Tobago's waters, where we are diving right now, has been previously studied by other researchers who were looking at mud volcanism, so specifically at these types of structures. And the reason they are prevalent here is because we are on top of this wedge-shaped pile or accumulation of sediment that is scraped off of one tectonic plate and scraped onto another. And here, that is the South American plate, which is going under the Caribbean plate, and part of the sediment on that plate is going down to the mantle, and part of it is scraped off and added to this accumulation of sediment. And over millions of years, of lots of sediment scraping and piling and accumulating. There's lots of pressure that builds up at the base of that pile of sediments, and lots of intense compression as that bulldozing of sediments is happening between those two as a result of one plate subducting under the other. And all of that squeezing can trap that water and gas as those sediments are progressively buried and get deeper and deeper as more things pile on top of them. And under the weight of all of that, you get really high fluid pressures that build up in that deeply buried sediment. And the result of that is those really high fluid pressures actually, this sounds weird, but like the particles that make up the mud are no longer in contact with each other. So what happens is that sediment turns into a liquefied mud under those pressures. And because that mud is overpressured, it's also less dense. So it's a lot of water that's pressured and not a lot of sediment. Again, it's acting like a liquid, and it's less dense than the surrounding material, so it's buoyant. And that buoyancy forces the fluidized mud up through these faults and cracks that are forming in that prism, and eventually it erupts onto the surface of the seabed. So we don't actually know whether this one is, I don't suspect it's currently erupting. These are things that happen over thousands or millions of years. But it's erupted enough in the past to have formed this mound structure that we are heading towards, and are going to collect heat flow measurements on either side of that mound. And one of the reasons we're trying to understand the thermal conditions is because if that mound is still connected to really deep in the subduction, in the prism, the accretionary prism, it should be warmer than everything around it, which tells us something about the plumbing of this system, how pressures are being relieved from deep in the system to the surface, how gases are translated from deep in the system to the seafloor. Well, there's another type of these. You see these like depressions?
Yeah.
These are also likely pockmarks.
Oh, yeah.
So these are basically areas of the seafloor that inflate a little bit under fluid pressure before they are, that pressure is relieved somehow, either by fluids being able to flow through the sediments, but when they collapse, they form these like pockmarks. So,
So you want to know something weird? We have this in the Laurentian Channel,
yeah,
Canada.
yep,
And we actually find distinct biological assemblages that are related to pockmarks, and we can't figure out why, because there's no evidence of any, like for biology, there's
Yeah.
no but for some reason, there's a correlation between who lives there and the presence of a pockmark.
Oh.
Isn't that weird?
Is it just that they maybe have reduced currents in the pockmarks? No, I don't know.
We don't know. It's weird.
I was reading something there in Trinidad. I feel, but it was about that they found off the coast of Oregon, I think it was.
Yeah.
But they think it's making the earthquakes worse. It's really all the fluid that was kind of keeping the plates apart. Somehow the fluid escaping, they're getting together and building up
Yeah.
their tension or something like that.
Yeah, there's so one of the
What's going on
that's
there on the
yeah, that is
on the left?
we like
That's strange, eh?
I mean, I
Can we
don't
go there?
are we allowed to
Are we on the
go over
I
transit?
mean, we did the
No,
last.
we kinda-
Yeah,
we did
so
the
let's
last
just
one.
check
Yeah,
it out.
that looks really
Weird.
Is that from fishing?
Somebody hiding a body.
Yeah. Good
Yikes.
place to put it. Yeah.
It looks like
Also still got the mugs.
weird. That's somebody's track.
That's a
Maybe it's
track
the
from-
French.
Oh yeah. This is from the French researchers that
1980s,
were
the
here.
French.
You want to follow it a little bit?
I mean,
Yeah, yeah.
I don't know if we have the tracks that they dove on. I don't think they dove on these.
Uh-huh.
This was just mapped using
Right.
bathymetry. Huh.
Can you see a parallel one to the left?
Yeah, well to the right.
Or to
You
the
see
right?
that, Dennis may be fishing.
Yeah, it's
I think
See
it's
the doors?
fishing. Yeah.
Two doors.
Yeah.
I caught it kind of in the middle, so it goes
But
behind
there's
me.
nothing in the middle, so that's the thing about the
No,
doors.
there shouldn't be anything.
Yeah.
If
Oh
it's
yeah, look,
fishing.
there it is. There's faint.
It's on the right too, isn't it?
It's on the right.
Yeah, there.
Yeah.
Yeah, it's fishing doors.
So fishing, I guess this would be an anthropogenic something for the log.
So leave it.
Yeah.
Yeah.
We're going on to 1507.
Yes. Yeah, so one of the potential mechanisms for contributing to the timing and size of earthquakes is fluid pressure. So Cascadia in particular, which is what you're talking about, is one of those places that experiences a different kind of earthquake mechanism. They have a big one every 400 to 500 years, but in between we have what's called slow slip, and they think that is releasing the same amount of energy as a single earthquake, except it's happening over an entire month, and they attribute that to elevated fluid pressure. It might be something you might be talking about. One of the what's that thing called? You mean is it a volcano?
It's like just a big, like a vent, but like a high flow vent, like a
Yeah.
whole lot of fluid coming out.
Yeah. Oh God, I forget what it's called. Oh yeah, your water percent.
Thank you.
Yeah, of course. Yeah, and honestly, we didn't even know about slow slip
No, we're not.
earthquakes until we started instrumenting everything and realized that Vancouver Island all the way down to Oregon is experiencing this sort of phenomena that's like basically slow earthquakes.
How did they even figure that out?
They figured it out by putting in tons of seismic stations and using ocean bottom seismometers. So they put these seismometers offshore in an arrangement that allows them to do they're just passively listening, and they do like 1 or 2 year deployments and then bring them back on board. And in some cases, they do like amphibious surveys where they have seismometers on land and offshore that allow them to look at the interactions.
Is this waypoint 2
We're at waypoint 2.
or
Go
1507?
for it.
Sorry, also known as 1507.
Okay.
All right, so we have landed at our next heat flow location.
It's not that big.
Is that the water?
It's not that big.
Isn't it interesting that it?
I mean, this is all within a 100th of a degree.
Okay, never mind.
The whole scale is still within the
100th
100th.
degree. Yeah.
Yeah, so
It's always fun.
it's not as noisy as it appears.
Okay. Is it auto?
Yeah.
Yeah. Okay.
It's something like that, it's actually
Yeah,
showing
but
that
we're
you're
actually at 2.
physically at 2.
We are at 2.
That one's not catching up with Freedom
No.
House, but this one is.
Yes,
Yeah.
yeah. we'll just-
All right, so we are going to test the sediment to make sure we don't have some hard, concretion in the near surface, so we can safely make our heat flow measurement.
This would be 19.
All right, that's good. Soft and squishy, that's what we like.
Perfect.
Are you all ready?
I'm recording, so
Okay.
anytime you're ready.
Anytime you're ready. Sweet. All right, so you can tune me out if you've already heard about the heat flow measurement, but what we are doing is we have on the side of the sub, we have mounted a heat flow probe on a track, like a hydraulic track that allows it to move perfectly up and down vertically. And that's important because what we're really after is an estimate of how temperature is increasing beneath the seafloor. We know what the bottom water temperature is, and we are first using that probe to insert about 60 centimeters of a lance into the seafloor, and there are 9 thermistors embedded in that lance. So initially we can see in our data some frictional heating from putting that into the seafloor. And then after about 7 minutes, the frictional heating decays so we can actually measure what we're after, which is just the temperature or geothermal gradient. So that gradient of temperature increase as you go below the seafloor. And that's one of the 2 components we need for estimating heat flow.
Sir?
And for people like myself and postdoc Robert Perrin, who's with me, heat flow is the ideal tool for understanding fluid flow in subsea floor systems, because if you have water that is coming from deeper, it will be warmer water. And if that fluid is translated from deep where it's warm to the surface, it's bringing that heat with it. And over time, that heat can warm up whatever structure it's coming out of at the seafloor. And in this case, that would be 2 small one small and one larger mud volcano. And that would look like, in our data, we would have an increase in heat flow as we approach this mound. And so we're going to go, this is our second measurement coming up to it. We're going to try and do one on top of it if it's soft enough, and then two more in between the smaller mound and the larger mound that I think you can see on your screen. I am very excited about point 3. How does it look?
The gradient, I mean, it looks good. We'll see where it levels out. Right
Yep.
now, the gradient's higher, but we're still on the
Yep.
cooler. So.
Cool. So broadly, the objective of this whole research expedition is to provide a census, a biological census of who is occupying Trinidad and Tobago's ocean, which makes up a large part of Trinidad and Tobago, over 93%, maybe?
It's
Yeah.
full of scuba depths, but it's 70% is deep ocean.
Okay, 70% is deep ocean, 93 is scuba depths included. Okay, below scuba depth. And really, there hasn't been an effort to either map this region or take that census. And we've selected, based on that goal, 7 or 8 different biogeographical locations within those waters that are I've chosen to be representative of the different faunas that are part of those different depths and ecosystems. So it's primarily a biology-focused cruise. And geophysics is useful in assisting in those goals, primarily to understand how fluids are and fluid systems are aiding in providing the structures and platforms for those animals in the form of carbonates, which are a process that is facilitated by fluids and chemistry, creating those carbonates. And then also we're here to provide assistance in all of the mapping and trying to locate methane seeps, which are really in the deep part of the ocean especially, that's the primary attachment points and building blocks of the communities that we've been looking at.
Two minutes till the heat pulse.
Okay. We're gonna do it again?
Oh, we don't have to.
Okay, we can. What do you
Oh,
think?
right. Yeah, we
Yeah.
can skip it.
Okay,
So 2 more minutes.
okay. Yeah, the second part of the heat flow measurement is, or the second part of estimating heat flow is estimating thermal conductivity, which is how easily different layers of sediments transmit heat. And to do that, after we get the thermal gradient, we fire a heat pulse, which means we're putting a known quantity of heat over the entire length of the lance. And then the way that temperature decays after that heat pulse tells us the thermal conductivity, or can be used to calculate the thermal conductivity. And those two things together are what gives us heat flow. And for those just joining, we are offshore Trinidad and Tobago on the accretionary prism, the Barbados accretionary prism, in an area where we hope to see some mud volcanoes.
max zoom.
Love.
That's thanks to our friend, the
Okay, we're good.
sea cucumber. All right, we're good. Good. Thanks. That was a close up on the products of a sea cucumber's travels across the seafloor. Okay, so we're gonna start a biological transect, 300 meters towards our next waypoint, which is on the little mound. Oh yeah, we gotta get him out first. Sorry.
Are we done with the flow?
Yep, we're done with the flow. We can take that up. Sorry. This one we're only doing the thermal gradient to half the measurement. We're going to assume that thermal conductivity did not change that much over a short distance. Yep.
Can we set up the waypoints?
100 or 300?
Every 100. So mark
100. Okay. Do they know that?
they should.
Okay. Yep.
Yep. But there is this, so then if we see something exciting, like
Yeah,
200,
sure.
we can just drop it because we know what to do.
Yep.
We can stop.
Nice.
$300 meters.
300 meters with a point every one. Or,
Ah.
yeah.
Every 100.
Every 100. Thank you.
Go ahead, Dorothy, up to your waypoint.
There you go, dude.
think a little off the line. A little north or south.
Okay.
Is that like a meter across? Right next to a depression. Might be fluid pressure, yeah. So, I'm gonna keep talking about mud volcanoes. So, one thing that, oh, hello. One thing that is connected in this particular region is earthquakes and mud volcanoes. Trinidad regularly experiences earthquakes, given to the fact that it's next to a massive accretionary prism, and the top of Trinidad is actually being pulled apart by a strike slip fault that is basically the boundary between the Caribbean plate and the South American plate. So there's lots of seismicity in this area, and I talked before about how fluid pressures can generate liquefied mud really deep within this system. And earthquakes are also capable of liquefying sediments. So if you've ever heard of soil New Zealand, the South Island of New Zealand, when they have magnitude 7 earthquakes or even lower magnitude earthquakes, what happens is you have a seismic wave that's traveling through the ground that is basically shaking these deep reservoirs that can cause gases and fluids to generate more pressure, and that process can lead to liquefaction and eruptions. And there's a couple of really famous examples that are eruptions that happened on land where an entire city was covered in mud by what is suspected to be, and is still in debate, under debate, drilling related to oil and gas exploration combined with local earthquake. And those two ingredients together led to the perfect storm where a massive amount of mud has flowed for many years and ultimately covering up this town. Obviously we're underwater, so nothing that dramatic can happen here, but earthquakes can trigger mud volcanism. Should we,
Might be rocks.
might be? You see that?
What?
The,
Yeah. But we're gonna go for it, Rachel.
huh?
I didn't just watch the lights.
Yeah,
Did you just stop?
no.
Just did.
Oh, you didn't hear it? Sorry. That was, yeah. I don't think she heard that we started a transect. Yeah. Sorry, Charlotte. I think we're 100 meters in. It literally started at the last waypoint, so you're okay. Yeah. Yep, sorry about that. I always think I'm so loud that I don't need that.
Sorry, you guys.
No, it's my fault.
When we flashed the lights?
Yep.
Yeah.
Yep.
Evident.
Yep.
Make them up.
Every
Yeah.
time it happens, I'm like, oh no. And then-
Yeah,
And we
freaking
just
out.
flashed them again, right?
yeah.
It's freaking out.
Make them all
I see that looks a little different too.
Yeah, it does. So how far away is that?
Far it's
100 meters, 50 meters.
Oh, should we just
40, 50.
do a jog or
But don't we see the same?
up in front? Not as strong.
No, it's more like a depression up here, I think.
Yeah, it's a depression.
Huh.
Let's go to the depression and then see what it looks like, and if it's nothing, yeah, we can stop the transit and make a jog.
Well, it would be easier to just go there now, right? Rather than come back.
Do whatever you guys like.
Yeah, we can pick up the transit later if it's not.
You mind heading over that way and we can pick up should we pick it up when we come back on the
Yeah,
line?
so why don't we end the transit here?
Okay. And transect?
So you want flashlights again?
Yeah.
Right, we can go and then if it's not, then
Cool.
come back.
Yep, perfect.
Okay, so stopping it and heading down.
Right turn.
No, we're going really slow. Let's see if it's cool and then stop.
Yeah, it's 50 meters. What's 50 meters at the seafloor?
It's 50 meters between friends.
Yeah, exactly.
Giant pile of gold.
Yeah. Retirement's early.
No, it wasn't. That's why. Or J.O. Kind of something. If they give you better.
Yeah, we're taking a minor detour because of something that showed up the sonar. That may or may not be interesting, but
Take a look, Rick.
take a look.
See some color. Something different.
Yeah, oh yeah, something's there. Oh, definitely.
Huh,
Oh, it's just these biogenic rocks.
There's
Yep.
a rock.
it is, it's carbonate. This is a good
There's
sign.
two berms on it.
Yeah.
Okay. Okay.
Oh, there's more rocks.
Yeah, this is just the start of it.
Yeah.
Alright, so we don't have to carry on the transit. Just
Yep.
explore here.
No, we'll
Yeah.
explore here a little bit.
Yeah, you can stop it for now.
Oh, yeah.
What are you, Gerald? Okay, great. You stop the movement, please.
Oh, that looks
Right,
man-made.
coming close.
Oh, yeah.
Big net,
Oh,
thank you.
yeah.
Giant net.
So much.
And what's under the net? Is that just
Nice.
animals?
It's not a super big spot,
Wow.
but there's more in the distance.
Yeah, no, I see that. It's like this whole bowl.
You see on the sonar now,
Yeah.
all down
Oh,
here.
there's
Oh, yeah.
clams. There's clam shells.
Yep.
So, yep.
Okay.
Yep.
It's another
Delivery.
seep. Huh?
To you.
Oh, and a ray.
Where's it?
Skate. Oh, it's skate. Where's Beatrice?
Scared.
There it is. So we
Okay.
should do the flyover, make sure
Yep.
we get enough video
Yep.
of that skate.
Sure. Zoom in on that little gal.
Is it a gal? What do you do?
I think it's female because you can tell
It's no clusters.
it doesn't have the, what are they called?
Clusters.
Claspers.
More polite.
Thank you. I mean, I'm always going to be the one to say the wrong thing, so. But I learned from hanging out with these people. These genius biologists. Yeah, she is cute. All right.
Should we use some lasers on, lasers
Yeah,
off?
just to get a sense of how big she is, and then we'll zoom in on her eyes and the spines on her back.
Just gotta change which course the lasers get blocked.
Oh,
That makes the abs look way up.
okay, she's, yeah,
Safe.
yeah.
Okay.
Cool.
Is that enough, or do y'all want to sit down or something?
I think just maybe get a sense of how big the area is.
Just kind of sweep around.
Yeah. Make sure we didn't miss anything, you know.
There's
Sure.
definitely two berms under there.
Yeah,
Yeah.
just this area, or the ones in the sonar further out too?
Yeah, I think maybe a wider fly around because I don't know what's happened. Whoa, whoa,
Oh, yeah.
okay.
Yeah, it looks pretty extensive.
Pretty
maybe.
extensive. Huh. So definitely an ancient seep site.
There's still some seepage because the two berms are here. Not
Yeah.
a lot,
Not a lot,
but
but
some.
yeah. It may have. Oh, cool. Yeah, this is way more extensive than.
Yeah, we weren't even expecting
It's
to
like
find
a-
anything here, right?
Yeah. Well, it's too small to show up on the imagery, but
Get more
it's in
raggedy.
the, yeah.
More raggedy the further we go south here.
What's that black? Oh, that's just sarcasm.
Sargassum.
Yeah.
Some corals.
Little corals.
Have you learned that name yet?
What is that?
Stylastrid?
Hole over
Oh,
there.
yeah, so we dug a hole, huh?
That's quite
Gotcha.
weird.
Oh, somebody's home.
Yeah, that's what I'm trying to zoom in on.
Maybe a crab. Crabs are like those kinds of homes.
It's a crab condo.
Wow.
Knock, knock.
Crazy.
Pretty big lately.
Yeah. There's not a small hole.
No, that's what I'm thinking. Maybe crab.
Oh, is that what, is he in there?
I don't know. That
No.
looks like a
Shells?
shells.
Shells.
Shells. So
So it's
Crab.
a dragon. No,
it's a crab that drags
it's a
in
crab
its
that
shells,
drags in its
pulling in the shells and
its
eating
prey,
them.
and that is so cool. Okay.
What's that?
Would come out.
Wild. Okay, I've just not seen that before, but again,
Alright, there's a pretty raggedy structure I'll go check out, and then I gotta move the boat a little.
Okay.
It's just 20 meters ahead.
And then we can head back to our mud volcano-esque.
Yeah, we don't want to miss the.
We don't want to miss
the
that.
part there, right?
It might be.
There's eruptions going on there.
No, no.
This is just the
The
trailer.
mud
Don't-
is flying
yeah,
over.
no.
I
It's
know.
just the trailers
Everybody
moving
was
and
getting
stuff.
right. That
Yeah.
was good yesterday, trying to manage expectations.
Yeah, I would like to temper expectations.
Yeah.
Huh.
Advice for life.
It is. It really is. Okay, so there's another. So there, it looks like there's just seeps
Yeah.
all over the place here.
About 20 meters from that, whatever it is.
Oh, look up to the left there.
Yeah,
Is that-
this is a large carbonate
Yeah.
structure. Two
Oh.
berms. Wow. Okay.
Cool.
Ah. Boomerang
Seeps
Yeah.
all over the place here, huh?
Yeah.
shells, boomerang shells. Wow. Look at all this circulars.
And then
Not
up
more
ahead.
net.
Another net.
Yeah, another net.
I guess
Ugh,
they get stuck.
more
right? They
more
think
fishing
it's-
nets.
So it's interesting. They
Yeah.
probably think it's flat and it's mud, and then they have these patches, and then it gets, and then more trash.
Okay. Well,
Like
heading
so.
back.
Okay,
or
yeah, let's head back. That was cool.
Mm-hmm.
A little diversion there.
Yeah.
Do you want to put a waypoint?
Yeah, let's put a waypoint here and
What do
just
you want to call
call it seep? Oh, seep.
Offline. seep.
Offline seep. Yeah. Seeps. Yeah, we aren't in.
Oh, and there's one line down there. Wow, yeah, it's.
I'll go back to the line a little different way, so it's
Yeah,
the
sure.
stuff.
And
Yep,
then,
perfect.
depending on how far we are, we can pick up the transect again, or do another 100 meters, or not.
You know how to do a marker there, Mike?
Marker or waypoint?
No, non-waypoint, a marker.
What's the name? Offline seep. Offline seep.
Off transit way.
I'll name it Bob. Let's call it Bob. Just kidding. Don't call it that. Did you see that, Rob? Another seep.
Yeah. Looks cool.
And now we are starting to go up towards our mud volcano. Maybe. We think it is. Climbing.
We're climbing.
Fair bit of that stuff.
Oh, yeah, next.
So we're heading back.
Oh, shit. Oh. Communities at Seeps. So if this volcano is active, it might be bubble streams, but we're probably, it's not. Let's temper our expectations.
It'd be sad if we don't see lava.
I know. There's not gonna. I mean, it'd be cool, but there are pictures online of active mud volcanism at the seafloor.
Can you see anything, or it's just a mess if it is?
Is it? You mean at the seafloor? Yeah, it's like. I mean, the pictures I saw are like iconic. You know, like one in a lifetime things
Yeah.
that just like it's burping, because of all that methane gas. Oh, looks like.
No little stuff.
Alright, so you would like some zooms of communities at seeps so we can identify them later on.
Okay. Like it, that one we just went to, or like
I
in the
think,
future?
yeah, the last one we went to.
So they go back.
For the rest of the expedition, sample the white, big-eyed Glyphocrangan shrimps. Somebody know what that is? Big-eyed. The white
Go back to
ones.
the line.
Okay.
Oh, those are the white ones, yes.
Yeah, the white shrimp.
I thought we did that. Didn't we do that?
I'm not. I think we did, but not intentionally. Maybe like a slurp sample.
Yeah, let me see.
Alright. So. Huh. Alright, here's another cool structure.
Whoa, with a big fin on top.
Whoa,
That's pretty
okay, let's
cool.
hang out here for a minute. and
Oh,
do some
wow.
Zooms. Cool. Although it
Gonna
does.
have an intercept,
What's that? Yeah.
I suspect.
Oh.
Look
Very
at that
nice.
bamboo coral.
We'll have to do some zoomy zooms on this guy.
Fairly scenic.
Yep. Picked a good high point. Oh.
Oh,
Cool.
there's a spotting on it.
Squat
You
lobster.
guys are about to get taken.
Two of those. Three of those.
Three of
You're
those.
about to get taken over by BBC in a minute.
Yeah. You are correct.
Three.
And, crinoid,
And a crinoid? Where's the
up in
crinoid?
the corner there.
I'm gonna come around. She's
Top
Yeah,
right.
let's do a fly, like a.
Top right.
Yeah.
I'm up current to this guy, so I'm gonna blow him
Yeah.
on this side.
Yeah.
Yeah, hello.
We knew it.
We heard. We
We know it.
predicted.
Your ears were burning.
Yeah, it was like, at 3.
How
2,
long will it
yeah.
take?
But there's two. There's another one over. Yep.
It's
Yeah.
a pretty scenic little rock too. It's like.
I mean, this was not even. We wouldn't have seen this on the multi-beam because it's too small. Not planned. But yeah, there's two little ones over there.
2, 3, 4, 5, 6. 6 of them so far.
Six squat lobsters. Yeah.
But it's
And
got-
then the white one, as well, right? Isn't that also a squat lobster?
It's like the white tree of Condor.
Yeah. This is beautiful.
And there's a,
Pretty cool.
How close can you get time?
I could
Whoa.
run into it if you want.
That's not too bad.
That would be the closest.
That's too close.
You want to run with me?
This is going to be a tricky one. Hold
Yeah.
on. But I think we can do it. How do you feel about an angle looking up at it, John?
Yeah, that's
Let me
fine.
just show
You
you.
okay?
Look at all the tubes down below.
So there's squatties,
See,
crinoid.
it's on this weird bridge. This
Yeah.
would probably be a cool one to kind of circle around. too,
Yeah.
if you want.
Yeah, we
Yeah.
can do. Do you want to do that first?
Let's
Yeah.
do the park stuff first. 'Cause I
There's
don't want to
also
hit the polyps
sponges,
side.
sponges on that side.
I might blow it otherwise. It's undisturbed at the moment.
Also,
Yeah,
it's like
what is-
such a dramatic, yeah.
what
the
is
crinoid.
that?
Such a dramatic outcome.
a second. Plus the coral is
It's like one of
healthy.
those-
Beautiful, plus it like is a really good visual. Try to find
6 inches long and they make a little.
Yeah, it's hard.
Yeah.
It's up.
Yeah.
Carrot,
It's a little weird.
shrimp. These are, not shrimp.
This is a weird little bridge.
They're,
Tell you that.
not little worms. Yeah, those are circulated
It's
worms.
like crumbling.
Yeah, so I gotta sit on the seabed for this.
So
So
this is
hopefully
fun.
that'll work.
Yep.
We'll see.
There's some
You want to be
mussel
close, you
shells
say,
there.
Johnny?
Dead. They're dead.
Close and looking up is
So-
okay for
He,
you?
he ghosted us. Yeah,
That's
he'll be back.
It's not, yeah, there's no
Oh, I can see
longer
it.
fluid coming
I'll
out.
just do what I think.
But what happens is, and the reason we have those corals up here is that
What do you
the
think it is?
structures
It's a
here
worm
in the
shell.
coral can go up.
No, is it?
So
Oh, it might be.
it's actually now it's pretty active. What's going on under the?
Oh, can we
Yeah,
keep an eye on
Is
the?
that an
yeah.
anemone?
Exact, just figure
Yeah,
out.
there's an anemone.
Yeah.
There's nothing over there right now.
Okay.
No.
Good.
That's right.
It's mud on that side.
Once
So
I
this
sit
is a
down, I'll
great
just
place
stab
for
it into the
corals,
ground and
right?
hold myself down. Is that okay?
Plant shows.
That's what, we,
Oh man,
that's what we've been doing.
this
here.
guy is full. Of, oh.
All right, Johnny, I'm pretty low, so you're going to be angled up, but there's not too much I can do because that ridge is super crumbly. So if I try and sit on it, it's going to knock it over.
You get the position you're happy with.
Okay.
But it will be easy to fly around this after. All right, you can go ahead and get the light. Just careful not to knock the stuff over if you can.
Yes, sir.
Could you?
Of course, that hose is all
Hi guys, welcome back. Zahir here with you for the next few minutes. We're just gonna remaneuver to get some shots of some awesome sponges that we have on this outcropping. Thanks for your patience and welcome back. So we saw some really cool sponges on this outcropping. We're just gonna zoom in a little bit to get some imagery for identification purposes. Sponges, as we know, are filter feeders. They take in quite a bit of our seawater, filtering out nutrients and at the same time extracting DNA that can be analyzed by our researchers to determine what type of organisms exist in and around the sponge's habitat. And a special shout out and happy birthday to our very own Shirley. Happy birthday, darling. Chiton.
Sorry for what? Ah, it's a chiton.
So, chitons, some sponges that we're interested in, squatties, as we call them, squat lobsters, many tube worms on this carboniferous rock. Majestic outcropping topped with bamboo coral, I believe.
That's all coral rubble down there, is it?
Yeah. If you could get on any sponges, just for. Rob. Rob. Yeah, that's good. Yeah. Yep. So we happy with the frame grabs we got?
Moving on?
Yep, we're gonna head back on our
Yeah, that's good.
path to our waypoint number 3, which is on a short mound. Some really interesting imagery on this outcropping.
Yeah, we can just keep it over there. When you fly. Coming up. Picture's gonna go dark as so coming up.
So just pulling away from this really majestic outcropping, crowned with a white tree
You can turn that off.
in inverted commas. It's awesome. So we're back now exploring, looking for our seeps on our mud volcano. Hopefully we encounter some new stuff. That was really awesome.
Look at those barnacles, beautiful.
There you go.
Could we just get a zoom on that again?
Yeah.
Yeah.
Looking down a little lower. It's kind of weird, huh?
Yeah. He's out in the middle. Usually would be around some structure.
Good light for you.
So you just want to grab some imagery of this.
A piece of. It's gotta be a piece of rock under there. Somebody hiding. Beautiful, yeah.
But fish in general like structure. You tend to find them congregating around
Beautiful.
outcroppings and around standing stones, etc.
Okay. That's the outfit.
Yeah.
We were seeing that probably one laser last song, but I'm not sure.
We can disassociate them, so they either get the whole thing or not.
Sorry? No, the lasers, I mean.
Oh, the
Like, I
laser's
seen
on,
only
yeah,
one
yeah.
was on. Okay, there.
The lasers are
Oh,
on.
they're
but
here,
when you have
they're
fish
on.
cores on, it blocks one of them. Which is
Yeah.
So we usually see barnacles attached to hard substrate. So this was interesting to see it out on the sediment. So we're proceeding along to our waypoint number 3. We're at the foothills of a small mound. The foot of a small mound. And you see the gradient changing as we go up.
Until birds they can resume their move there.
Where are you, Dorothy? May you please resume the move to the waypoint?
Yeah, waypoint on the way now.
Thank you.
I think now we start wanting that soon, huh?
Yeah. Some panade shrimp. You see the angle change as we head up the sea mound. Some urchins as well. So we continue our quest for our mud volcanoes that we got a glimpse at when we were mapping. Just need to get eyes on them to confirm. And mud volcanoes are geological features formed when water, fine sediment, gases, primarily methane, and fluids are forced upwards through tiny cracks in the seafloor. But unlike our volcanic mountains on land, they don't erupt in the what we know as lava, molten lava. Instead, they expel things like cool mud, water, methane, and even other hydrocarbons. They can be quite small, ranging from a few meters to upwards of several kilometers across, and can be active for thousands of years. And buenos dias to our listeners from Argentina. Good luck in your game later. This mud originates from deep down in the sediment, buried hundreds to thousands of meters below the seafloor. So some of the mud that you're seeing coming up in some of our mud volcanoes is quite ancient. Those of us from Trinidad, we do have some mud volcanoes on land down in a region called Piparo. So as the sediment becomes compressed, water is squeezed out, increasing the pore pressure at those cracks. And the gases building up underneath, like the methane, further increase the pressure until the mud finds a pathway to the surface through these faults and fractures, as we see some sea cucumber tracks in the sediment. So why study it? Because this ancient sediment in the form of mud can provide a lot of clues to our geologists and geophysicists about the geological history of the Earth. They can also transport materials from deep beneath the seabed to the surface. They release methane, an important greenhouse gas, as we know, and it's a concerning one for us at the surface. Although much of this released methane is consumed by our microbes and our chemosynthetic bacteria. So we just have a shift change. But from the biological standpoint, us biologists are interested in mud volcanoes because they can be biodiversity hotspots, areas where you can find a host of different organisms, so large diversity. Things like tube worms, like Lamellibrachia judigobini, for example. Sure, no problem. Just doing a little bit of housekeeping on the ROV. Other organisms that we tend to find around these mud volcanoes are mussels, or deep sea mussels, and clams, both of which contain the photosynthetic bacteria similar to the tube worms. Some of them even host sulfur oxidizing bacteria, and sulfur is one of the compounds that tends to come out of our mud volcanoes. Other crustaceans like your crabs, your amphipods, your squat lobsters like we saw earlier are also common around these features. And they act as a link between the microbial community and the the organisms that exist higher up on the food chain and food web. Some of our larger individual organisms, like our fishes and octopi, also do frequent these mud volcanoes and these cold seeps and our hydrothermal vents. But also interesting is the wide array and diversity of corals and sponges that we tend to find here. When I was younger, I thought that no coral would exist at these depths and at these temperatures, but the diversity down here is quite awesome. We don't have the coral reefs that we have at the surface, but we do have a host of different types of corals and sponges, deep water corals and high latitude corals. Many of them being seen for the first time. Just some minor housekeeping, as you may hear some chatter in the background. Our ROV pilots are making sure we get the best imagery possible, so they're just adjusting some lights and some cameras.
Oh, we didn't.
We're
Were
just
we
testing.
actually doing the transect? I don't think so.
No, we're not.
No.
No, they're testing something.
Oh, okay. Just happened to be right under 300 meters.
Yeah, we're just advancing up this very interesting mound. As we see a skate on the right. The ever-present royal red shrimp. And one of his, I believe, Cariday cousins. Seafloor littered with mussel shells, typical of areas close to cold seeps. Wouldn't it be something if this mound were a geological feature, a volcanic feature? So as my time with you comes to an end, just want to say from the midnight zone to your screen, thanks for diving deep with the cucumbers and corals today. This is Zahir signing off from the deep sea where the pressure is high, but the thrill of discovery is even higher. I'm going to pass you on now to my colleague Shauna, and you will be in good hands with her.
Who's got it?
Very smooth.
Yeah. Okay. And the selections on it. Hi everyone, this is Shauna. Hey, joining you after Zahir's excellent commentary.
Okay, so which one do you prefer? Okay. Yeah, we can.
All right. Skate.
Yeah, can we take some time to take size and look at it well? And, yeah. Oh, never mind.
Well, we have another one.
The other one's there. We'll see if it stays.
Yeah. Please, yeah. With the lasers. Yes, you want to get some good imagery of it. Oh. It's only one of the lasers came out.
He's tilted down. Tilt up a little bit there. And up a little bit. There are only two lasers on it.
Mm-hmm.
And up a little more.
There's only one laser. Oh, the chance of bird, yeah. Oh. Yeah, so yeah. So you think when we push forward?
When you tilt down too much, one of the push going block.
Push bars. Push bars here.
The
The handles for the push bar, when you tilt down too much, it blocks one of the lasers. Don't tilt down anymore, okay? That's all right. I'll try to get you in mind there. Start zooming in easy. Zoom in. Okay, stop there for a minute.
Plus, I want to. How long do you think that took to settle?
It's clearing now. Zoom in a little more. Other way. In.
Zoom in.
Zoom in, yeah. If I get any closer to him, you'll swim on.
Yeah.
Zoom out a little bit. Okay. Let me try to get a little closer to it. Like get too close to him. Try to zoom in. Focus. Okay, good.
Good. So if it's the land, you get like some stable video. Or
Um,
you frame grass roots, you think would be
let's
okay.
just get some backgrounds from here, so we have, hold on.
Yeah, some frame. Maybe we could zoom in a little bit more.
Try to zoom in some more, Marco. And as you zoom in, you need to adjust the focus, right? Yeah, good.
Nice, yeah.
Perfect.
Could we get some like, could we kind of zoom in on the top? Yeah. Oop. Oop. Could we get like of his tail as well? Please. Am I too zoomed in for you later?
Yeah. Zoom out a little bit there, Mark. Okay, there's the laser. Zoom in just so much that the laser is just
Just
in the
before it goes away, yeah. Yeah.
too much.
Yeah.
Okay. Pull down.
Nice. Good.
Well, look at your,
Top.
other stuff. No replies, yeah, hold on.
Move on.
Yeah, it's always a good idea to keep your wets up because there's a lot of sample and no sample.
Okay, I think we can move on.
Okay, zoom out. Okay, I'll take control of the
How far are we?
roast.
This is definitely lovely. Yes. How steep it is.
Follow these shelves and continue on.
I think we're continuing along the line.
Throw clams. Yep.
I'll start the T minus countdown already.
Yeah.
Around it. Stop it or keep on?
Let's see. We want to conduct heat flow measurement at waypoint 3, right?
Yeah,
Thoughts?
we can.
Yeah.
find it.
Yeah.
Yeah?
He's right at the top.
Okay.
Not right now.
Spot reading ranch.
Yeah, so we want to conduct a heat flow.
Yeah.
Say anyway, kind of go around here that's flat or as close to the top and or as close to the top as you can. You let me know what looks like a good spot. You let me know what looks like a good spot.
Yeah. Basically, if it's flat, we can land.
Okay, yeah. Yeah.
We'll do no less caliber.
Please.
Yeah. We're gonna come in shoreline.
It looks pretty rocky.
We should try.
That'd be,
We need to see where the flow goes.
make sure it's safe. It looks
Okay.
good now,
So
but it's
What do you
Yeah, I
like
know
now?
what you're saying.
Get a
like
caliber
kind of
out.
small spot to set down.
Yeah.
Sure. Yes.
I can watch?
Or I can stand back and just talk to the pilot.
If you want to talk to me, you can set it. I'll watch. It's next time.
So I can't, does it look like there's soft stuff over there?
We'll see what caliber tells us.
Yeah. No, I know, I'm just more worried about right under the probe.
So what we can do, if here is pretty good, we can tune the RV 90 degrees and put the RV.
Right where it was. Thank you.
So it should be that little monkey that's right in the corner front there.
So we are on what
Put it
appears
in
to
the
be the
ground
summit
recap if you want.
of our smaller mud volcano that we have planned to include on our transect today, and we've collected a couple of heat flow measurements leading up to this mud volcano, and now we're at the top, and it may be that there's enough carbonate in the area that we can't safely collect a measurement, but we're going to see.
If you're on the ground, yeah, that one, you hand it to yourself and yeah, you should hand it to the port arm and then grab it. Just do not handshake.
Two-handed.
You can grab the body or the rope, anything on.
Getting set up to put it. Maybe a little closer to the sub so we can avoid the rocks.
Yeah. Put the laser right where the laser is. It's off now.
Boop. So I guess just have to be really careful when we try and put the probe in.
Okay.
We've had a couple where it moved the sub.
Yeah. Freeze your arm there and okay. It was on before.
Left side, yeah.
Okay.
Rob, you ready?
I'm recording.
Okay.
Yeah, it's going.
Sweet. Right. Okay. Awesome. Thank you. Lauren.
Yeah. This is them.
Yep.
Just don't touch this.
Yeah, just you can't tell where there's a rock.
So just rotate to your right.
But
zoom
it's
in.
not.
It's good. Yeah. Great.
Just pick something.
Shana, if the escape is in proximity, you got. Escape is in proximity, you got the instructions. If it's not, it's just. Yeah, yeah. So it's up to you. Yeah. This looks too interesting. Oh. We need many of those. How many? Oh. Try, and you don't have to.
until we get the curve back out of the ground. Yeah.
One orchard.
One is the shrimp.
Okay, I'm doing this
So
side.
brown over there, one on
Round.
down.
For me, 3.7. No, we have a transect, but not right. That's a round question.
Hi, that's good.
Yeah, so if we could get like 2 of those shrimps.
When they're in their little bar, they're a bit tricky to get out on the edge. And, or like that. We feel
think so.
fresh, but they're enormously infamously strong when they're grabbed off the rocks. And they make up for the play. Sometimes, or real track.
Yeah, the problem. We want to be sure someone's using it on the sediment.
What, the shrimp? Yeah.
Shrimp is only
That one? Okay. Alright, so we got them first one.
like 2 of those shrimp.
Let's see our second one. See if you see.
I think.
There's 2 sport lobsters on the rock. Most. Okay. Zoom out there, cancel it, and zoom into the shrimp there. On the left of the arm. And zoom in, have a look at them, and then look around and see if you see another one of those shrimp somewhere.
There's a shrimp there
Where?
on the far side of the rock. Swimming, you see a shadow. There's a stick. To your right. 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 Right.
So keep your eyes peeled for another one.
Yeah. 1 is okay, 2 would be great.
But the 18 will get it there. We're gonna leave it pretty soon, yeah. The 18's coming. To get the RV down, get it ready, bring it there. Just have to go over the 18. Yes, we're gonna do more on the cover.
No, I was gonna say.
Sometimes we get like an hour, 2 hours on deck and then back in. And they come up like.
Are you guys done? Or are you still moving?
No, still waiting.
Okay.
Like,
Yeah,
every
just trying.
sampling option exhausted and doubling up on buy one solution.
No.
No, there's a lot of stuff going on, so we'll just also look at the
Yeah. So now.
sonar, yeah, and the stuff going on, so we'll move on. Meander.
If the heat flows, collect the shrimp.
Yeah.
Cool.
Yeah, well, that's another one. The last one is we use the RV one.
No way, good question anyway.
So what the time to come back and get like cold feet and planks of wood and stuff like that. Like hoops and rings.
Thanks, bro. Maybe if I can go to see what comes of them.
No, but they have a plan already on how to. So what that's for a lot of
Well, we need to see the, it's a,
It's a male?
well, I can't see from here,
Yeah.
we need to, when we're done, we're still measuring, when we're done, we can check it out to see if it's male, if it's male, we're gonna need a light. Can we zoom on him to make a decision now if it's male? It's too far.
So are we still going fish room or are we going video?
I think we'll go for the octopus first because we get some footage.
Because you may not see that in Tobago.
Yeah, it's too far, we're waiting, we're doing a measurement,
Ah, okay.
so we can't get more. So listen, but we're trying, so we're trying to see if we can see it. It looks like,
Because the trip
That's
is
the-
right there.
The third right, right?
yeah,
Third
After.
right.
yeah, so, yeah.
Why are you so successful?
Oh my god, adorable.
So probably something like that.
Where is he?
I zoom out of the location. Two dots there. That really is
Yeah.
right beyond it.
Okay.
There's 5 minutes left.
Fine.
So any changes in the instruction there?
Anna?
Yeah.
You want to prioritize
Octopus.
The octopus, right?
Yeah.
Where's the shrimp?
So I can front or there.
That's so cute.
Mine, the unexplored, but it's out of egg. Yeah, that's right. No, I like. So I did go with Trinidad.
Mm.
And so in this pipeline, and there was like a coral reef all around, and had this not a lot man. So some Goliath, like huge, real big. It was so big you could see it on your sonar swimming towards you.
Still going wrong?
But reach out until you identify what they're looking for.
That is so interesting. You know, I have no bones.
Do you consider the carbon?
Do they have a beak?
Yeah, yeah, octopus have a beak as well. You didn't see the beak in the one that you guys covered?
I do not consider that bone.
You what?
No, I don't consider that a bone.
Keratin.
Yeah, I think so.
Maybe I should not, okay?
Is it going good?
Part of the game. The last week's cruise, my shift was doing most of the flying because we were doing nighttime dives. Okay, my guys,
Good to go?
Yeah.
Okay.
Okay,
Get
taking
on
it
the heat floor.
for up. Yeah.
And if we do collect, how do we collect the last one?
The octopus with a net.
Oh, yes.
I think if it's male, we're gonna have a bit of a segment happening, so, like, people are gonna storm into the rooms.
Okay.
So let's just first check, see if it's male.
How do you know if it's male or female?
Okay.
The third
Take
arm on the
out
right
and
is
stood.
shorter, and sort of to grab the female.
Shorter.
Yeah, and it has, and I know.
Yeah.
I know.
Third arm.
The third from the right.
Okay.
So we need to get close and zoom in.
Up there, where he is already.
Yeah.
Put some lights on it.
Mm-hmm.
So, okay. This is a map. We're gonna collect it. I understand that Schmidt is gonna manage like optics, because last time we did it, there was a background. I know, so,
Yes, I'll change the camera.
so you will give it a,
I'll swing to a different camera.
yeah, it's up,
We'll
but
show
I'm
them
just, yeah,
the
I'm
wall.
just checking, yeah. Yeah. Is this on? This is on? Why is this on? This should never be on. It should never be. This place, it should never be.
nice. See them?
That's not my fault. I'm just suggesting.
Yeah. No?
Let's just zoom in a little bit more, but
Oh.
stretch it out, good.
No. Well, female.
Zoom out.
It's a female, so I don't think they're interested.
Well, we're not gonna fill that.
Oh, well, hello.
Is that a shrimp you want there?
Yeah, so should we?
You see?
Sure.
Oh, is the shrimp still there? Why
There's
don't we have-
one right there, is that the same there?
If you could zoom in to get a look.
Zoom in on that shrimp
They have, like,
there.
googly eyes.
Yeah. Yeah, it looks googly.
Thoughts on it? Never mind. Yeah, I think we can continue. I'm just gonna highlight them. So we want to stay around the top of the mound or continue on to we went for another
What's
round?
going on with the shrimp?
That's C1, yeah.
Yeah, just carry on to the waypoint.
Oh.
Unless we do something, see something. We have it.
Yeah, so we want moving towards waypoint 4, we're just going to go all the way around the side. We're just going to keep it in the super
Not much shrimp, right?
Is this shrimp?
No, it's the white one.
White, right?
Yeah.
With eyes.
Yeah.
With the eyes. Go ahead.
Could you move the vessel, move the waypoint, the vessel, like grab on the FKT and just put it outside the red zone. Yeah, and just tell the vessel down. Just tell them to go to the new waypoint.
Ready, gyro Vic?
I don't be great.
Can you move to the new waypoint?
Sure, no problem on the move.
Yeah, so that's.
Yes. Can we take a look at it?
Yeah.
Any living mufflers?
She's not producing details in the weights there.
Move back? Back. Zoom back.
Zoom out.
Yeah. Move on? Move on. Thank you. Oh, is that a great channel? Shout?
That's not our channel.
Yeah, it is, right?
Yeah.
You wanna take a closer look?
Zoom in there, Armani. Nice. You want it? Don't think so. Check your. Check yours.
Yeah. Hit this. Give me a second.
So.
The
You can ask. Or I can ask. Three of them were false. I'll show you a picture. I took some pictures.
let's double check that one.
Yeah. So one of them, the clamp wasn't on properly. So it wasn't even on the acrylic. It was.
Is it one minute? Let's go get it.
I'll take a picture. And two of them weren't told in pressure and how the O-ring was seated properly. Do you fill the bucket up like full and totally submerged?
Shake so it holds the water.
I'm not trying to get it.
No.
I'm just telling you. See if you can see correctly. No. So this is the acrylic there. So the entire
Okay, we should keep going.
You know,
Sorry?
it's one on the acrylic and one on the bump. The black thing goes on. So it was swollen pressure. Yeah. Just not just handing
Yeah.
over, right? So like if you want to pull this out, nothing is pulling the bung on to the seam on top, right? That black was supposed to be done.
Keep going.
So that was
It's not
past the
wrong. I think we can.
So I was telling Claude, he was saying it was scientists who put it together and they just put it on the check. So is that what you did? You don't have to do that. My job is make sure it's on the colors properly. Put it in the holes. Two of them were So just moving on. Station heaters on, auto motors on. Have fun. Ta-ta.
Thanks, honey.
Take it easy.
Yeah.
We'll do an hour each. Is it? Do an hour?
So moving on to waypoint 4. Just keep an eye out for anything interesting. I don't bother into the concept. Right now.
Who's for this? 1499? 1499, heading back. Yeah. What, my white west? Different. That's the viewpoint. We keep from here.
Mm-hmm.
Base, here we go. So, yeah, 1499. Let me jump out. Bridge Arvin.
Harvey Bridge.
Morning, Tom. Waypoints updated. You'll forget to me.
I'll tell you what,
They did a transect before me, between 1 and 2. We'll move into waypoint 4. We were gonna do a transect, but Anna said to bother. We just look around and see what's interesting. They're looking out for a male octopus and some white shrimp, like large googly eyes. But yeah, they're kind of just looking around to see if there's anything of interest to stop them to go look at. Like any like high density sites.
Did you get any?
No.
See ya. Thank you.
Bridge RV.
Harvey Bridge.
Why are we heading south, Tom, towards the RV?
Stop. Stand by.
Huh?
Oh, for.
Harvey Bridge. Leave it right now.
Is it lift gate?
I didn't try going downstairs.
can go to the ledger. Did you try?
Slowly.
Did you pass the inspection?
I guess I don't think so.
You haven't received any stickers. You haven't received the notifications.
Oh, no, I haven't.
Yeah. That's why because we're going downhill.
Yeah.
It's just gotta
Yeah.
ride with the rear.
Yeah. Where on the vehicle is your altimeter? In the center? Yeah. Yep. There's a bump.
you get the hermit crab? At least I think it was the hermit crab.
Do you want one of these white shrimps on it?
We do.
Just one.
Okay, we need to stop and, well, unless it's gonna be a mess, in which case we can not see it. Again,
Another one, I think. Yeah.
it's another one, yeah. So we need lasers on it for size and all those things.
Any particular size you want, or any particular size you want?
No, one or two. I would say section jar.
Section.
Two.
Okay.
Birds are big. Can you pull some in, please?
Pause in a minute.
Yeah.
Yeah, it just went off to the right. Tricky little guys.
Try and grab the
There it is. I just moved the camera slightly.
There it is.
Yeah. I was gonna say I saw him in the camera for a second. And he's swimming. Alright, keep an eye peeled for him. Oh, this guy over here on the left.
Yeah.
That's a little squatty, I think.
Yeah. That's right.
Perfect, there it is.
That's right there.
There's one.
Running away already
Okay.
before we even landed. Oh,
Just riding the cloud here.
For Charlie.
Continuing the move.
There's one on the left. Can never.
Pretty much,
Okay.
Yeah, it was good dress. Good week. Not gonna happen. Oop. Oh, close. What
There's
happened?
another one up there.
Oh, there it is. Oop.
Another one up there. No.
Is there a particular canister you're watching?
What is going to one? I think we
One,
got
one.
Kid you know.
One or two. There's
There's,
no.
There's
No,
one?
I don't think so. No, that's nicer, I think.
There's one?
No, I think squats. Oh. I'm getting so small I can't differentiate. No, that's a squat lobster. Right.
Right at the edge of your shadow.
One money. To come out in. Come down.
No World Cup unless we get
Yeah.
one of those, you know.
movement outside the screen. I would move it. I would come to the.
Another
left
one
or
coming
right.
across here.
Right on the ground.
Yes. So anytime I stop and come down, that's it.
Yeah. Slow mine out.
Go on. Big one. Take it. Take it.
Another one up there. Yeah.
It's long.
Mm-hmm.
And let your money.
Oh.
Come. Pick him. Hit him.
Nope. When they swim right back down in front of the screen, it's just extra injury.
Come in center of the screen. Feel free to have mine. One minute.
No.
No?
No, that's a squat.
Yeah, these are hard to control.
Get it.
RV bridge, sorry, can you repeat?
Your white points up there.
Don't stay away from it, thank you.
One. That's good.
Yeah, that's one. Choose one.
Sleeping man.
Shit, off the screen of that.
One there. Right in front of us.
Scoot back a little bit more on transect.
Like a net for those shrimps? Maybe to just like the net.
Too big.
It's too big, the net, the mesh.
I don't think think so.
This is waypoint 4? Where?
Are we at?
Almost.
Almost.
RV bridge? Do you want me to continue the move?
Yeah, you could come to boards.
Coming to a stop.
packed away, or yeah? Because once they're in there, they're staying.
No bottom trouble.
Best way to grab this is forward like this, not like this. Because when you have this movement, if you have this movement, you have it more. Which do you want to move that one? I think on this.
Harvey Bridge.
Yeah, but I want you to like maybe
Harvey
call you're
Bridge.
gonna see the one sec bridge. Keeping it in front and just like comfortable. Yeah, bridge, you could continue to move.
Yeah, continue to move.
Try and keep it close. That's fine.
You happy for this net to be out front of the camera for a while?
Yeah,
It's okay?
it's okay. I just got that shrimp.
Big one?
No, guys. Then why? I didn't even see that one. That was shrimp. Oh, lobster. Actually, it's a big shrimp. No, it's lobster. No? Yeah, maybe.
Go ahead. Yep, next one.
We've got some flying around.
Bring in your elbow. Okay. See the start there? It's too straight. Bring it in. So you have that one. Nope.
Close all that.
I'm sure they're like, what is going on?
There's one on the left. To right. Keep
That's
going.
one in front of me.
Yeah. Two, actually.
Is it in?
Yeah, that's
Yeah.
one in there.
Yes. Yes, it is.
Yeah, it's they're reddish. Like they'll stick in the net, so there's no getting around it really. So I don't know, you might want to catch two before back to back,
Yeah.
or however many they want.
Just 1 to 2.
That's us. Courtney?
Yeah, we'll go back to four. Or one.
Another one.
It's a big guy.
Yeah.
Is that the right type?
Tom? It's very red.
It's funny, they're everywhere, but they're very active.
Yes. Everybody's active. Look at that urchin. It's going
I
where?
know, yeah.
They're
Urchins
just
can
running
definitely go
around.
on. Yeah. One to see it.
Have we passed waypoint 4?
Yeah.
Oh, we have to
Yeah,
do
we
the
haven't.
heaps.
We'll have to go, we'll have to stop.
Wow, okay, I think,
Yeah, we're just past 25 meters.
well,
Oh, there's
my
one
ships.
right there.
Do we want to?
The worst is they just like stop on going. Where's that now?
Yes, all right, great.
Push that sucker up.
Yeah,
Thank you. Thank you.
Nicely done, pilots.
nicely done.
Back on.
Excellent coordination between pilots.
The big firebox.
Well, I guess I'd say the smallest firebox you can fit it in.
Yeah.
So after.
Yeah, heat flow.
Can you go back?
Go back?
Yeah.
Okay. So 1.99 is the waypoint?
At waypoint 4, yeah.
No, I mean, like, just so I have an idea, it's 1.499.
I think so, yeah.
are we going for it?
It's only, it's quite big, guys, so I think it's only gonna go in the big one.
Yes, yes, we're going to.
PB1A.
What number is this, Juliana?
PB1A?
Yes. But what number sample?
This will be 95,
952.
sample ID 422.
Can't see one. Hold up. Good job.
Okay, great. Okay, so can we turn around and go back to waypoint 4, please?
Yes.
Waypoint 4 is almost 150 meters away.
Yeah.
Guys okay with that?
Yeah, because we have to get the heat flow.
Yeah.
Bridge already.
Harvey Bridge?
That's all waypoints updated, we're just gonna go back a bit, 150 meters. So we'll go this down.
Full copy of waypoint today, get us down, thank you.
think a fish?
What was that? Can we go back?
Yeah. It was like a.
Are we transacting?
No.
Can we go back to see what that was?
It was like a serpiente.
It was like a fish, but then doing
There was
something.
something else.
Might have gone by
Yeah,
now.
like,
Yeah, I mean, I can see that, but like, looks like a fish maybe hunting something.
Are we going back to waypoint 4? Does it have to be exact at waypoint 4?
It can be.
Like, can it be now? We're not that far from it. Are we too far from it?
We could do it right now. Yeah.
Yeah.
I just didn't want to. We were almost halfway to it.
Yeah, but we don't have to go all the way
Yeah.
back.
It's
If
probably
it's
fine
good
right
enough,
there.
that's
Yeah,
fine.
it's
But
fine.
if it's not, then we can go back.
Okay, I think it was a long shot anyway. Sorry if it was.
No.
Oh wait, that's piece of it. It was. I think it was a fish.
That
eating
looks like
whatever
a
that is.
fish. Is it
Can
still?
we get a zoom, please?
Mm, nope. Oh,
So I think it was a fish eating the cube. But interesting. Anyway. Okay, thanks.
yeah.
We can do the measurement right here.
Okay. Okay,
mine
can we
was the
get
asphalt
the
one.
heat profile? Anywhere specifically to place it? Oh, I can place it next to the bed bug.
That works. Oh, and then we're taking a measurement. Yeah. HF 21.
heat flow.
Yep.
Which one? 21?
21.
Okay. And pop that down right next to the decapitated body.
Do we really want to do it in front of a dead octopus? Yeah, that may be good.
Something happened to it.
Zoom into the core or whatever, and then we're staring at a dead octopus. Yeah, that's good.
So I'm recording so you can put the probe in. Yeah. No. We haven't been. Delta. So we're not gonna collect the equals. No. Yeah. Yeah, we were chasing the shrimp past it. But we went almost halfway to 5, so back to place.
Where's that?
is similar to the ones on the other side. Okay. I think it's just because I don't want it too obscuring. Oh no, oh yeah, that's it. So I think it's still, it's colder than you would think. It's colder than you would think.
It's not
I'm not sure. Yeah, it's kind of funny. Okay, that's good.
Okay, can we take it off, please?
You leaving?
No.
Because we didn't, she said no to
Yeah, that's
This is
true, because
where
they're looking
I-
pretty flat, so we can do it.
Do you want me to go back to the very start, or?
Well, if we can fit 300 meters, I think we can fit 300 meters. If we
Okay.
can, so. Make sure we have,
Enough space.
well, no, make sure we have markers and make sure flashlights are a
Yes.
little marker.
Okay.
Because we may, if we see something cool, we may cut it short, so we need to have 100
Okay.
non-standard total.
What's the distance between Okay, well, can we go back a little bit more to 0.4? Yeah, just because we need it 300.
It's 320.
This is what you're going
No, no little buffer.
This can probably
It's quite
have
annoying,
the-
this buffer. We can get back to it.
If y'all think we can fit the 300.
We'll go back to it.
Not all the way, just a little bit. Great.
It's a secret number.
25.
Huh? How much?
25?
Yeah, like 25 meters.
Yeah. Oh, well.
We can start here.
Okay.
We can
Yeah.
start here.
Okay.
We don't have to go
Never mind.
nowhere.
Start saying video transects.
No?
1 minute. We have to slow down a little bit more. Okay. Good. Start. Start.
Stop.
Yeah. No. This is second one.
952
Oh, flash the lights, please.
Bridge RV, waypoints updated, we're back moving to it.
If you could flash the lights up.
Here's the lights flashed.
Waypoint updated, back moving to the east.
Yeah. Every 100 meters from.
RV Bridge, I've just moved the waypoint myself by accident. Are you ready to move it back? Sorry.
Yeah, there you go.
Cheers, Tom, man. I'm having a very good day. I think.
We all have.
But yeah, speed bumps you could catch up to.
Bridge RV, can we come 0.6 please?
Going up to 0.6.
Okay. That's important. Hi, guys.
Good afternoon, everyone joining us online. My name is Sharice, and I will be with you guys for the next hour of this dive. So we have just begun a transect. So when that happens, I always say we don't get to stop and look at the organisms if there's anything really happening, unless we come across potentially a seep, at which point we may stop the transect. But these are very important because scientifically we want to know what is along the seafloor, and even if it may seem like not, it may seem to sound like not much is happening, that is still the data that we need to show about what we're seeing. Look at that urchin go. See that?
That's all we can bring the speed down very much.
They got it. I was looking at the one.
So it's very hard to have one.
I know. Between 1 and 2, we got a little too close to it. That's when I kind of.
So what's altitude not working? What's altitude not working? It's quite flat.
Yes, I think it's with the map of the pictures.
meters. That was the flashing lights, then? Thank you. Yeah, it doesn't have to stay exactly on one, but you can go into like the 370. Cool jelly. Drop it just a bit. A little bit. Like 1.2. that the flashing lights? Lower than 1.2? Can we lower it a bit?
Yeah, 1 second.
Yep.
Jumps. Seabed isn't flat sometimes, so I'll just think it will. You check it goes up or goes down. It's very few times because I'm auto altitude right now, so it's trying to maintain this 1.2. Sometimes I drop to 1.1, 1.3.
We'll try to maintain maybe 1 then, potentially.
Altitude?
Yeah. Yeah, I think that should be okay. Your favorite dog, transects. What?
So the on deck time for this dive is currently 1900 local time. So we're looking at just under 6 hours left here. That's going to include ascent, but of course we're shallower almost by half. So more time still to come.
Big sea cameras. For 3.5. Yellowsaur.
So you can see we're coming up to this larger mound here. And we did see some signs of bubbles on the northwestern flank here. So we're going to see if we can find those and then continue making our way on to the top. Hoping to collect some push cores there before we leave bottom, but that is the plan for the rest of the dive.
Yeah. Yeah, we've seen a couple of these guys. One, they can swim like the rest of them. Two,
It's huge.
Get them to fly. Open up eye
And slammer shot.
Yeah, we've tried it, but they're so big.
Yeah, I know. Well, one came that it was cut in half.
I know, yeah. I'm trying to think what the biggest dive we got up on. We got up on
Oh, one of
the
those.
gummy squirrel. We got one.
Oh, yeah.
Not on this
Intact?
one.
Intact?
Oh, yeah.
Oh, wow.
I'll see if I can find you the photo. The scientists were hyped about it.
I'll let you know on the flash
What is that?
Porters.
Cyclopodes.
Yeah. Cyclopodes.
Yeah, good.
plate with your transect.
That's the end?
Oh, so plates are in good.
Good.
Do we just explore to waypoint 5 and then do a heat flow at waypoint 5?
That's it.
Alright, so we completed our video transect. We're just going to head around to this point mark just pretty soon.
That's interesting.
And then from there
Sweet.
we'll let Rob do his stuff with heat flow.
That's not our photo, but I'll find you ours.
Do we know what heat flow number is?
This would be 22.
22? This is waypoint 5 now, right? Okay, so can we set that to do the heat flow?
Rich, can you just continue that one until you're level with the elevator?
Yeah, continue later till I can get over.
Oh, the probe is dragging. That's fine.
Alright, so we're settling down and we're gonna take out the probe to begin our heat flow measurements, which take approximately 15 minutes, and we have Rachel coming in. Do you want to discuss heat flow or you want to?
The bottom of the probe is in seconds.
Let's wait for it to cool before we do.
Yeah.
So do we not take it out?
No, it's
No, we just have to wait for it.
Yeah, just the sediment.
Just when we
friction.
landed, the probe hit the ground, and so it heated up. So we just have to wait.
We can test the sediment.
Do you
No,
want
what
to-
is that?
This little guy?
Yeah, this one?
Yeah,
Looks like a little halosaur.
it's tiny.
Teeny tiny little dude.
So do you want me to
Test the, what's
test
that?
the sediment?
You got this. Yeah, well, first, okay, sediment.
Poke the sediment. Looks pretty soft.
Yeah, but we'll test how soft.
Soft, yeah.
Get any resistance?
Softest sediment yet.
Oh, wow. like soft serve ice cream? Okay.
That feels like butter.
Yeah, we just, unfortunately, we need to still wait a minute.
Yeah.
Well,
Is
there's
it-
no, it's they're flat. That's the problem. Like I wonder if it's bending a little and it's affecting the canisters. So if we just go up and then straight down,
Okay, so bring
If we-
the
yeah.
probe up and
because
then
if
straight
it's
down again.
if it's bending, that's
If it's bending, is the probe bent? No.
okay, and just let the water cool it off, and then just set right down,
Okay.
but like gentle.
Do you want the water to cool it off longer and then set it through?
It just happened, yeah. Alright.
One more time.
Well, we can't frictionally heat the probe, or we can't get a measurement. That's, yeah.
So we'll stay for a little while.
Let it cool off?
Yeah, just give it like 30 seconds to cool down in the water column,
Yeah.
And then set them.
and try to like really ease
Yeah,
down super
just so it
slow.
doesn't.
And if we can get land as easily as possible.
Yeah.
Oh, wow.
We got it up in the bio box.
Wow.
Okay, it's
I
cooled
guess the
down
big
now,
bio
so we
box.
can
Yeah,
just-
yeah, it didn't have a division or anything.
Alright, wow.
Super hyped about it.
Oh, that's surgery, yeah.
Yeah, yeah.
Oh my god, that's massive.
Yeah, that's cool. So we got that in the bio box, that was a big news. Yeah, that was one of the octoliths. I don't remember. Must have been the first one.
Yeah.
I think it was here for. Still touched?
Yeah, we'll just give it. Yeah. They're at least cooling down this time, so that's good.
Slip down here.
I think we're on like a
Looking great.
Oh, that's tomorrow, that's what's that.
move again.
No, no, I think it's coming down.
Yeah, we just
takes
have
a
to,
minute
we just have to wait a minute.
Yeah, whenever it frictionally heats, it just, you'd be surprised how much temperature changes.
So don't set it in yet.
Not yet.
No,
No.
no, no, no.
Happy birthday, Shirley, and that's sediment.
That's right.
Oh my god, that would be hilarious.
Do what? Right, happy birthday, Shirley? That would be great.
But not while we're doing a heat flow.
Yeah. What do we shoot with a probe?
How
Let's
good
take
are you
a
with that?
picture.
Can you do that?
I'll do a job.
It'd be something.
It'd
There'd be marks.
be like, look like someone had a stroke. Tried to write something. No, it says Shirley, obviously.
Well, we gotta do it like, like flight path through the snail
yeah.
trail from our road.
Oh my gosh.
Yeah, like that guy
That
that
would
was
take
there
some
is on
time.
board and all those things.
Yeah,
It's
yeah.
just.
Well, if we have the M3 on, do it with the M3 on, and then submit that to Jebco. It
Yeah.
would be the highest resolution map for the area, so you just get like, happy birthday. Because you can find some, if you look on Jebco, you can find like people that have done like stars off the coast and stuff.
Oh, yeah.
I think we're okay, so. Okay, I'm recording now, so we can insert.
You can insert.
Do you need the front one?
It's
22, right?
Yeah.
Correct.
Look at the, there's mark.
This is the 5th.
Because I was
And
like,
last. I'm sure everyone's
22.
happy. For today, anyway.
Oh, is this your last one?
We're going up towards the seeps now.
Yeah, so you're done? No more?
I mean, if we'd like one on top, but
Okay.
I don't know how soft it's
Yeah. Where's that?
We'll be with it. That's all it
Uh-huh. So we could definitely like,
Oh, the stars.
we can definitely like have the breakfast, right?
You got like a fish going on here, I guess.
From. This is a good bit and shit.
Some artists out there.
Yeah. It's not often. Usually it's the grids, but like you'll find a star. That's fun. Is it useful? I don't know. It's fun.
Yeah,
And
that's
if you
fine.
guys become
More
so
important.
good, you would want one of
Yeah.
those.
There's seeps there.
The crown?
Maybe. Squiggles for sure.
I guess you guys would burn in and stuff.
Yeah, we see something.
Oh, here you go. Symbol for
Do you want to tell us what they do?
fish. Well, yeah, it's a fish, but it's
What
not
you
a
see, and then lines.
It's been displayed.
The new people joining in, and then would love to hear from them.
Yeah, I think so. Let's just see what it is. Oh my gosh, now it's just all pretty over. Nothing good, nothing public there. These are all just public ones. That, that's a project.
Definitely.
That's a project.
Which one?
This guy
No,
here.
see, look.
Holy cow.
I know. How
Oh,
long
that's a
would-
3D seismic, isn't it?
Yeah, that's
Gotta
pretty
be.
wild, huh?
Yeah.
Wow.
Oh yeah, that's 3D seismic.
How long do you think that takes?
It takes a long time.
Whoa! Is that Hawaii? What is that?
Hawaii.
Yeah, Hawaii.
Yeah.
We're tense, the neighbors of the south.
Sure what this is. Hydrographic. Noah.
Hawaii. Well, that's the.
American Samoa.
Oh, there's a lot of deep sea mining prospecting going on up there.
Yeah, I think the stars are probably pretty unique ones. I'm sure other people have done, but whether it gets submitted to a big database.
That's an interesting path up there. Southern Ocean. I wonder if that's when they were looking for them.
What? Are you serious? You can.
No, you did. Hashtag trophy What?
How do you know that? Did she say that? Where?
They said in this.
Oh.
house fire, and then you'll see another one of those control curves.
How often does that happen?
Every measurement, 5 minutes. So you insert it, it warms up, it goes in, let that last to flat. What it gives you is temperatures that it does. And then you fire a heat pulse, and then you use that kind of curve to estimate the activities.
Okay. Then you'll need to do one.
Yeah. Because one's sufficient. In reality, it's not very much between all the places we've got there. And so we'll end up with like 5 of them.
Okay.
And they'll be very similar.
Okay. Got it. But in like a very different environment.
Yeah, so up here will be different than, say, the abyss. If we went like really close to that, there's a lot of percentage coming off the continent.
Okay. And this is why you say sometimes you go wood and go wood. Have things been like today?
Yeah.
Really?
Well, the one on the top's was good.
Why? Like,
Not
what were
sure
you
yet.
expecting versus what we got?
Expected it to be higher than what's surrounding it, but it was colder.
Oh.
So
Why did you expect it to be higher?
there's food coming.
Got it.
There's a couple of tuberums up there, there's mussels and stuff, so I think there's something seeping
Okay.
out. It's 5 more minutes.
I was looking for the stars over here.
And then we climb this and then look for bubbles.
Oh, I'm okay. Well, there is one
So the program is essentially back once you want to the program is actually back if once you want. That's what they say.
Oh, I didn't know
the first part you said.
The pro it's actually back. But when you is it immediately inserted or is it daily inserted?
They answered it. It should, like, so it's kind of flush with the basin of the lab of Sebastian. Once we sit and test run it on the step.
Really? Jelly.
Okay, we're good.
Okay. All right, so we finished our heat flow measurement. Yay! Thank you, Rob.
We'll see.
We'll see you again at waypoint 6. Maybe.
We'll see.
Alright, so what we would have just been doing was heat flow measurements, which is essentially they put a probe down into the sediment and they look at the conductivity as it is in there over like about 15 minutes. And that essentially tells us like how heat is flowing or like how fluid is moving within the sediment, which is important, especially when we're looking at seep sites where there is that kind of like seepage flow happening. And if you were tuned in earlier when Rachel was leading,
Sorry,
you would have
Rachel,
heard all about it.
After the waypoint from your question.
I'll take waypoint, thank you.
So we're currently at the base of a mound, which we're thinking is a mud volcano. And as we explore, we are going to be looking for signs of seepage. That is like you typically look out for those methane communities that come up. So when you see bacterial mats, tuberums, potential muscle beds and stuff like that, that's what we look out for in those cases. Shrimp.
Yep.
Allosaurus. A couple of them. Benthic ctenophores as well, which is those like red things on a white stalk that you're seeing. See some bacterial mats. Oh, look at the sea star. Kind of chunky. Yeah. Is that? Was that an octopus?
Ooh, yeah.
Octopus.
Octopus. Okay, let's check it.
Oh, hold on.
Yeah, let's check it.
Yeah.
What's going on with the depth of that? Oh, that's a different. That's correct.
We have an octopus, guys.
very long.
Oh, they did it.
Very long. Girl.
Girl?
Well. Yeah.
Do you want to grab some images?
Keep going.
Keep going? Okay. Alright, so we think it's a girl octopus, so we've noted it in the log. We'll continue along. Let her die. She's very pretty. Yeah. I think it's on its way. Urchins, some bacterial mats, which are a good sign. More benthic ctenophores, a lot of shrimp. What's that? Big sea bed. Have you seen this one before, Anna?
We have,
Okay.
and collected it.
And we've collected, so we can Oh, there's a couple off screen as well. More benthic ctenophores. So many shrimp. Clamshell. No, actually that's a mussel shell. So these kind of fluffy, almost black and white things that you see across the sediment, these are microbial mats, which are typical of seep sites. So when you see those, it is a good sign. And then when you add in that we are also seeing some mussel clam shells as well, it's typically when we start really looking out for those bubbles, for those seepage areas. Oh, big shrimp.
Big shrimp.
Massive shrimp.
What?
That's a big
That's
guy.
huge.
Can we zoom in on him?
He's a swimmer. He's just chilling on the bottom. Yeah. Hey, bud.
Put those lasers.
Oh, it's majestic royal.
It's what, like, I don't know, 17 maybe? 17 centimeters?
That's a good 22. Those.
Yeah, I mean, look at its antenna, though. That's like
You got images?
half meter or more. Yeah.
Perfect.
Get rid of that. Away he goes.
Oh,
There you go. Oh, and
majestic.
Hmm? Beautiful, eh?
Yeah.
lounging.
those little legs.
Nice, real nice.
Back on track along this mound as we look for some more signs of seepage.
Yeah, something off to the right there.
Bunch of
Spot.
shells. A little bit of clown shells. Good signs, good signs. Again,
Part of it now. Yeah.
those ones up there.
So do you want to follow this or you
We're
want to
gonna follow it a bit, but it's just go up a bit and that's it.
This line, big line. You wanna go forward?
Where we at?
So this going forward?
Between, Ford and
I will be having all
so
of
there's
my
some sort of harder stuff. So just go up a bit, but then
Okay, so
maybe,
currently
there's
using
the
these signs potentially.
Ain't you half an hour over?
Sorry?
Ain't you half an hour over?
Yeah. So comfortable.
I don't know. Oh, what are you doing? You're
Taking a stop.
See if we can see what that is about.
see
Maybe
what
if I
happens.
can see that. Because we're seeing signs of like columns and stuff, which are good for trying to see.
yeah, so
Also,
go
if
up
we
the
see
hill.
this mound, yeah, if we see an octopus, we want to take a closer look just to see if it's male or female as well.
How can you identify?
Using some light. Oh, bacterial mats. Tubers. Keep going
Yeah.
to get to those two dots.
Straight across, so just to port, from the line.
Port of that one.
All these bacterial mass.
Mm-hmm. Yeah, so just keep adjusting until that basically comes into exactly.
To the road,
And then
to
we'll
Trinidad.
continue up the essentially.
All right, so we're all just looking for bubbles now. Bubbles and just seep communities in general. But We did see some bubbles on the sonar.
What is this? Oh, actually,
Ooh,
what's
off there. There's something at the base of this guy.
Yeah, there's. Yes, we could look down. See the top. Wow.
I almost had it over to you there when you said this thing. I know that for what am I doing?
No,
I
that
was
was good
like-
A lot of squat lobsters, some coral, bacterial mats, tube worms, seep communities. Yeah, we're basically on it.
Right, of course.
Okay. We're just doing a bit higher and going back so we don't stare up this where it is. See some mussel shells, clam shells, a lot of bacterial mats, which are exciting. See the squat lobsters in between.
Yes. Yeah. Oh, not from here.
No, not from here.
But we have it, yes.
Look at those little squat lobsters. They're cute. All good. Right, so I'm going to actually hand over to Dr. Diva Amon, who is the chief scientist on board for this expedition. She'll be doing the hot seat for the next hour, so it's exciting that you've come across a little community and she can tell you all about it. Bye, guys.
Thanks. To know.
We've done our transect. I've written down that we lost at transect 3 and then
You do an hour and a
2.
Wait, what?
So we did transect 3 when we went from waypoint 4 to 5. And then at 5 we did our heat flow measurement, so that's heat flow time 2. And then now we're climbing from 5 to 6, so it's up this mountain.
And then we're supposed to do a deep flow at the top.
Yeah, and we're on the next step to come in and see if it's possible based on
Great.
step by step.
Great, thank you. And which things are, which can pick, where are their animals? Great, perfect. Hello everybody. My seat is nice and warm.
It's gonna be a good one, I can smell it.
I also can smell it. So we can keep moving to waypoint
transects, and on the way we're looking for signs of seepage, hard substrate, high density communities, and we're already beginning to see it. So we're just going to progress slowly because I think there'll be a lot to see. Please. Okay. Good afternoon, everyone. My name is Dr. Diva Aman. I'm the chief scientist of this expedition, Deep Wonders of Trinidad and Tobago. Can we shut that off? And we are on our 18th dive of this expedition. Today we are exploring a mud volcano off of Trinidad's east coast. And what we're finding is we're just climbing this mound that we think is a mud volcano, and we're finding now carbonate rocks. We're finding evidence of seepage, which leads to chemosynthetic communities, a lot of things. And so what's happening here, perhaps some of you who have been on the dive before today or earlier today, is we have two plates colliding. The South American plate is being driven below, subducting below the Caribbean plate. And that is resulting in a lot of sediment and organic matter scraping off the top of the South American plate, becoming jumbled up and being subducted. And essentially that leads to the formation of, in some places, of oil and gas. And that oil and gas can often be linked to other sorts of seepage like methane gas, and that can lead to very high density methane seep, very unique communities. So we've been seeing quite a lot of those here in Trinidad and Tobago. And today, this is, a dive on a mud volcano. We're not sure, so far what we're seeing is that is manifesting as a big mound-like structure that is about 150 meters tall. And we are now climbing the side of it to see what's at the top. I should also say that overnight we mapped this area and we did pick up evidence of bubbles in the water column. And bubbles usually indicates, again, areas of seepage and therefore very exciting communities on the seafloor. So here we are. Let's see. We're just approaching the actual areas where we did see those bubbles right now. So we're keeping our eyes peeled for bacterial mats, which we're seeing every now and again. Those are the white areas of the seafloor. We can see some coming into view here. Also blackened areas of the seafloor. That's where the seafloor has become anoxic and become reduced. Wow, look at the sponge. This is amazing. And today is actually, side note, today is actually one of our two sponge experts on board. It's one of their birthdays, Dr. Shirley Pomponi. And she's celebrating her 77th birthday with us, which is really special. And she loves her sponges, so. So here we can see some of this reduced area, which indicates that there is seepage. We can see darkened patches and then the white sort of halos around it. And that is that reduced sediment where oxygen has been removed because of the presence of bacteria. And those bacterial mats are that the white areas on the sediment. And that bacteria is actually what, sorry, let me start again. The methane, which is used by the bacteria, is actually what powers the ecosystems at methane seeps. So this is all a good sign. Wow, a lot of halosaurs here. And we can tell they're halosaurs because they have this very distinct, long, elongated body, which is very still, except the last bit of the tail, which undulates. Very distinctive shape. What we've been seeing at some of the other methane seeps we've explored here. Can we just take a look at whatever that is over there? Maybe wood? Please? Is we've been seeing around there are these areas of seepage where there's big mussel beds and tube worm beds, but then on the outskirts of that is this carbonate with all of these other corals and other things. Wow, so this is a big natural woodfall. If we could just get some quick zooms here. And actually with me in mission control right now is one of my students, Eugenia Thomas, who is for her master's working on woodfalls in the Caribbean. So this is very serendipitous for Eugenia. But if we could just, set down here for a second or get some good views, some good zooms, sorry. So woodfalls are, let's start again. So essentially in the deep sea, food can be very limited. A lot of it comes from the sea surface in the form of dead plankton, dead animals, essentially what we call marine snow. And not a lot of marine snow actually makes it down into the deep sea. And so when there are these bigger parcels of food like wood or like dead whales or dead mobula, like we saw at the beginning of this cruise, this expedition, they create this sort of feeding bonanza. And animals from near and far come to feed on these big parcels of food. And they often end up with very unique and distinct communities from those around them and also concentrate life. So they're often a place to find new species as well. Wow. Okay, so what can we see here? Okay, so this is interesting. So we can see that there's some barnacles along the leftmost side. And that indicates that those probably came from the sea surface, perhaps. But then in this piece that's closest to us, we can see that it's very bored. There's a lot of holes. And one of the main animal species or groups that feed on woodfalls are wood borers. They have evolved to live on wood only in the deep sea. They're called xylophaga or pteridinids. And they essentially are perfectly adapted. They have these shells that have little teeth on them and they can burrow into and eat wood. And so they are a big part of what wears away wood in the deep sea. Also here we can see some squat lobsters. They are the little white lobsters. So Munidopsis, there's at least one species of Munidopsis squat lobster in the world, probably more, that they've only ever been found on woodfalls. So endemic to woodfalls. And we can see some tucked away sheltering. And so this is the thing, wood and whale bones can often not just be a source of food, it can also be a place for many animals to shelter. And what we're seeing here at the top is a place for animals to attach to. So at the top here, this is a benthic ctenophore. So we see a lot of ctenophores when we're descending and ascending to the seafloor. But this is a unique ctenophore in that it actually attaches to the seafloor or to substrate like wood or rocks. And you can see it's got its fishing tentacles like a normal ctenophore extended way out, which it uses to fish for animals and particles from the water in the currents, and then it reels them back in and eats it. So we can see all three of the functions of woodfalls here. It's providing food, it's providing shelter, and it's providing an attachment surface. The scale, for those who are wondering, those two lasers that are in the center of the screen, those are 10 centimeters, and that is what we use to gauge how big things are. So this woodfall is well over a meter in length, well over. And we can just see this community. We can also see a limpet living on it. And then another thing that happens at woodfalls is it's not just the consumption of wood, but during the consumption of the wood, when animals eat the wood, they poop out the wood around it. They might feed sloppily, and that leads to wood chips on the sediment around. And that actually enriches the sediment around the wood and leads to other animals that move in. So we can actually see a little polynoid scale worm just to the right of the branch that is sticking out towards us. There's a little scale worm to the right that's sort of blue in color. Anyway, so this is just a really lovely example of a whale fall. There's also something next to it that I have no idea what that is. This? I don't know what that is, but that's the scale worm. So there's a lot happening here, and this is a great little find we've seen here. And what's interesting is whale falls and woodfalls can often become chemosynthetic. Because of the activity around it, it leads to reduced sediment and often shares species with methane seeps and hydrothermal vents because they can be chemosynthetic. And so it's interesting that we're in an area of seepage as well as woodfalls because there may be overlap in the species that we're seeing at each. Oh, and so we can actually see all of these white shells to the right that are really patchy. Those are actually the shells of Xylophaga, the wood-boring bivalves. They've, I guess, maybe because the wood became bored too much and there's no more energy left for them, or there's not enough place for them to anchor themselves, so they have now died and fallen out of the wood, which is very interesting. Thanks, guys. That was great. Good little find. And we can see in the sit cam, I don't know if they can see the sit cam, but there's quite a lot of wood here. It's actually like 2 pieces. And you can see the shells of the Xylophaga all around it. And of course, this abundance of life brings in other animals. Perhaps that's why the halosaurs are here, to eat things that come in. They end up having their own little ecosystem. Yeah, that's really, oh, it's also barnacles. Yeah, super interesting. Really great footage. That's great. All dead. So this has perhaps been here for quite some time, or it floated to the surface and other animals used it for quite some time. I don't know what that brown thing is, but there are all these things. But anyway, this is great. Let's crack on. Thank you. Yes, thank you. We can keep heading up slip. So as we're going up slope, we're seeing also some corals living on the carbonates. Here, there's that orange coral is a Stichopathes, a type of black coral. Next to it is some other kind of coral that is hard to see, but some kind of white coral. Looks also like a black coral, but a different species. So someone is asking if those wood-boring bivalves can swim. They cannot as adults. Once they settle and bore into the wood, they will not ever be able to leave again. But what they can do, whoa. Oh. He has places to go. But what they can do is they can send out their larvae, their babies, that then are able to drift through the water and find new pieces of wood. So there's so many things that we have seen on this particular dive that we haven't seen anywhere else. We're seeing a lot of these white and pink shrimp, more than we have seen on any dive. Those are called glyphocrangon. These big craggy carbonates, we can also see on them there's some white tube worms. Those are serpulid tube worms called Neovermilia. And it's suspected they may be chemosynthetic or benefiting from chemosynthetic environments in some way. And then we've got lace corals here on the edge. And we've also seen these very much associated with seeps here in Trinidad. And we don't know whether Trinidad and Tobago, and we don't know whether that is because there's more productivity in that area, so they're getting more food, or whether they are also partly or totally chemosynthetic also. So it looks like we're definitely beginning to see a little bit more signs of activity. There are increasing patches of black and white sediment. Well, black sediment with white bacterial mats. A lovely bamboo coral there that has some crinoids on it. Not just crinoids, but also benthic ctenophores, also a squat lobster. And that coral has actually grown on a patch, what looks like a fossilized patch of these serpulid tube worms. Can we just do a quick zoom? Like, we don't have to settle down, but if we have any more zoom, a quick zoom on that, just because that's really different. Yeah, exactly. Yeah, so these are tube worms that have obviously become concreted together at seeps. That is a process that often happens. We can see some other patches around it. But yeah, this bamboo coral has actually attached itself to that. And we know this is a bamboo coral because if you look on the stalk, you can see the black nodes moving up the stalk, which are basically like bamboos. This is great. Thank you. We can keep going. Okay, more seepage coming in here on the left. More carbonates, carbonates getting more and more. We can see some of the other kinds of tube worms. These may be dead, dotted in between the rocks. They're larger and actually have a chitinous tube, so not calcareous like the serpulids on this floor. A lot of places where we can see corals once live, all of these broken off stalks of coral. A lot of also potentially fossilized, what looks like in some places fossilized coral around. And then we've got these beautiful lace corals, stylasterids, the white ones. You can see why they're called lace corals. Is this another one of the eggs? Either egg or sponge. So on yesterday's dive, we found what we think is a Dumbo octopus egg. They're known to attach their eggs to corals. And it did look very similar to this. So maybe that's what it is, or maybe it's a sponge. You think it's one of the eggs?
Looks like that one yesterday, yeah.
I mean, it looks less smooth. But then maybe that just means it's older. Shirley was here. She would be able to tell me if that's a sponge or not. Anyway, we can see some stylastoids above, a bryozoan that actually is sort of mimicking the stylastoids or has a very similar shape. This orange animal is a brazingid sea star, which you can see it filter feeding. It gets itself up high onto structures and then puts its arms out so that it can strain the water for food. And we're not sure why these corals many of them have died and just left the stalks. That makes it seem like they perhaps were knocked over, and maybe that's because this is an area where there is sediment that comes down the slope and knocks things over. Not sure. Oh, there's a big patch of tube worms here. Well, big being a relative term. But as we moved, we know that these chemosynthetic, these seeps or cold seeps, what we've seen in other parts of the world and in Trinidad and Tobago is they have these sort of zones, horizontal zones. So very close to the seepage, there'll be mussels and eel pouts and shrimp and lots of other animals. And then further out from that, there'll be these tube worms that we can see here. These are most likely lamellibrachia tube worms. And these are chemosynthetic. They are able to extend their root like a plant, kind of, though these are animals, down into the sediment where they suck up chemicals like methane or sulfides, and then through bacteria in their body, they use those chemicals to make food. And so they tend to be found further from the seepage. And then beyond, even further from the seepage, you get these rock-like structures with often corals and other animals on it. So it seems like we're getting closer because we've gone from the carbonates and corals, and now it seems we're starting to see the tube worms also. And that tube worm, actually, there's a really nice story attached to that. It's known from Trinidad and Tobago all the way up to the Gulf of Mexico. And it was actually named after, in 2014, I want to say, 17, somewhere around there. Recently, it was named after a Trinidad and Tobago professor of marine science. She is the first ever professor of marine science, Dr. Judith Gobin. So it's called Lamellibrachia judigobini. So it's something we're very proud of as a country. Another brazingid with a big stalked barnacle next to it, some lace corals again. So again, we should be, I think if we go for the most southern red dot, and then we can like try to, what do you call it? Connect the dots. Connect the dots.
Bubble signatures again.
Yeah, the red of the bubbles, exactly. We think. We haven't been wrong yet. Yeah. Again, here are some areas of seepage. Yeah, some areas of seepage right here. We can see again the blackened sediment, the white bacterial mats. We can also see, can we just get a quick zoom on that yellow patch? Because that might be like sulfur. Very interesting that it's so yellow. We haven't really seen something like that yet. Or at least I don't recall. So you can see some of the circulars just pulled in. Or Or maybe it's sponges? Weird. But here we can see two types of tube worms. So the ones coming out of the seafloor, those are, they may not actually be Lamellibrachia, they may be Escarpia. There are two chemosynthetic species here in Trinidad and Tobago. And the Escarpia tend to be more curly, more like windy, whereas the Lamellibrachia tend to be longer and straighter. And then we've got this different type of tube worm that makes these calcareous shells that look yellow here, but often are white. And those have to attach to rocks, whereas the other ones can just grow out of the seafloor. Oh. Yeah, it seems like sponge-like, right? So it looks like it's an encrusting sponge that's actually sort of grown all over this stuff, which is really interesting because it's an area of seepage and it's a yellow sponge. Could this be something we want to collect? Like, see if we can just grab a chunk of... Do you think that's manageable where we are? Oh, what about this? This patch down here.
We can probably reach that.
The one in front or the one just below?
Yes.
Yes to which?
You want this in a bio box, I guess?
Sure, whatever you think best. But yeah, either this one or this one. But if we just take a piece of it, and that will mean that we haven't seen this yellow encrusting sponge yet. And so it's really important. This is really interesting because sponges are often filter feeders, so they strain the water for food. But the fact that this is living in an area of seepage could mean that it also has chemosynthetic bacteria as well. So it operates with two different types of, I think we are going to have to break some, operates with two different types of feeding potentially. Yeah, that's great. That's perfect. I mean, it's okay if we do break. Okay, if it's like, I mean, it may be part of the seafloor.
This one piece broke off.
Concreted.
You want a pretty big piece though, right?
I mean, we would have liked, yeah, a piece that's...
We can get more than one, right?
Yeah, so that'd be great. But we also, I mean, we don't actually have any Escarpia yet. These tube worms down here. So if we were able to get some of those as well while we're here, great. And so by taking these samples, there's so much that we're able to learn that, yes, we get amazingly clear images. Like it constantly blows my mind that we are at over 1,400 meters deep in the ocean. And you in your living room, whether you are in Trinidad and Tobago or in Argentina or in Germany, can sit and watch this stream with just a few seconds delay. It's amazing. But images only tell us so much. It is very helpful to be able to have a specimen, and that is so that we can learn more about its anatomy, its DNA, but we can also, yeah, got a whole one there, great. We'll definitely take that, and then if we can try to get a piece with the yellow sponge, please. But you can actually see these tube worms if we get a quick zoom on it. So you can see the part that is actually buried in the sediment is that black color, and you can see it gets very, very thin. And this is essentially the root of the tube worm that it probably extended way further, and it's able to extend that down into the sediment so that it has better access to the chemicals that are seeping out of the seafloor. So these are beautiful samples. And given the shape and size, I would think this is the second species of tube worm that we have in Trinidad, the Escarpia tube worms, which is great. We have not been able to collect that yet for this expedition. So very well done, everybody. We can pop this away and see if we can just get a piece with the yellow sponge and then carry on. Thank you. And so this inside of this chitinous tube, there is a worm that lives there. And sometimes you can see it poking out of the end, a pink sort of end. And that is what it uses to get oxygen from the water. It absorbs oxygen from the water. And it then uses that oxygen to convert the chemicals that it is taking up via its root into food for the tube worm and the bacteria inside. And if you actually Google either Escarpia or Lamellibrachia, see if you can find some pictures of the worm outside of the tube. It is crazy what it looks like. They don't have mouths, they don't have eyes. They look very different from what you would think of or what we see as other worms in the deep sea.
Focus. There.
That piece that just fell off is great. Oh, yep, great. Yes, please. Wow, cool. Very interesting sponge. Great. Yeah, if we could pop that in to the bio box, wonderful. Same bio box as totes fine. Amazing. Thank you. That was 2A or 2B?
Was 2A.
Yeah. Sponge. Yeah, sponge and chew. What number was that, Bia? Or Eugenia, sorry. 423. Sorry. Great. Let's keep going. I think that one's a sponge.
Sponge?
Yeah, I think so. Let's keep it going. It looks a bit fluffy. Ooh, can we go a bit left? Just to see some of these corals. Earlier in the dive, we did see, it may not have been the same species, but squat lobsters actually eating a benthic ctenophore, which was very cool. Yesterday, we saw a sea star eating a coral also. So we're still not quite at the seepage areas yet, but again, all of these are sort of clues to show us, as we've been seeing throughout the dive, that this is an area, or certainly once is an active area, an area of active seepage, and certainly once was even more active once upon a time. Ooh, very interesting. Yeah, I think we want to keep following the hard substrate as we're going. Something else we've been seeing a lot on.
What is this? This seems like purple coral.
Oh, I
like
didn't.
A Victor Gorgia or something like that.
Can we just go back slightly? Sorry, where be at?
Just the patch of coral that we pass.
This one? No.
No, I think it's beneath you. Yeah.
This.
Yes.
Can we take a quick look at that, please? The purple coral down at the bottom here. Good spot, Leah. Really good spot.
I think it's the first one we see.
Yeah, we definitely haven't seen any purple corals so far. But maybe these are zoanthids? Do we have any more zoom? Or stolonifera? So here we can see three different types of coral or coral relatives. So we have the lace coral, stylasteras on the left, that's the white. We have something purple in the middle that is a stolonifera. No, okay, that's just a coral, right? And so can we potentially sample this?
But of course.
And then on the right, we have some zoanthids, which are actually animals that have colonized an old sponge stalk, grown over to form this sheath. Yes. So let's see if we can get a piece of this purple coral, please. Really beautiful. How big is it? Let's see. What's happening with our lasers today? I've often seen just one. Oh.
So we could take some of those out and put them in the quivers and it wouldn't do that anymore?
Got ya. I just was like, what's happening today? Okay, so I didn't really gauge how big they were, but I think if we can get a 10 to 20 centimeter piece, 10 to 15 centimeter piece.
You want that in a quiver?
Yes, please. Well, anyway, you can put it, but yes, if a quiver is okay, then that would be best. We can also see in between the squat lobster, some benthic ctenophores. And then after this, we're going to go to the seeps and stop being distracted, or the potential seeps. I know. What do we think this is? Like an acantha gorget? Mm-hmm. Yeah, great. Oh. Yep, agreed. So we can see two different types of squat lobsters here. One that is orange, that is very close to the piece of coral that we are trying to sample. And then we can see another species towards the right, on the left of towards the right of the rock. Amazing. Thank you. Very well done. quick zoom and then pop it in the quiver, please. Oh, we can see all the polyps have now closed up because it's been disturbed. So this is a defensive strategy of the corals, or defensive movement. We could just adjust the focus a little bit. Oh yeah, there we go. Beautiful. Great. Thank you so much. Let's pop that into.
Seems like that kind of pinky purple is very fashionable down here.
It's very fashionable.
Yeah, you see a lot of aquas have it.
Sure, okay, but that's our, this is our first coral in that color. And we can actually see with this zoom, which is so incredible, we can see sclerites in the coral polyps. So these are skeletal structures that in the polyp itself, you can see, wow, we can see lots of different types of sclerites. This is, again, absolutely amazing. This is one of the identifying features of corals. You have to look at how their overall shape, like the whole coral, but then you actually have to look at some smaller features as well. Great, let's put it away. And head to bubble patch, southernmost red, well, I don't know if it's southernmost, but closest to the bottom of the screen. I have no idea. I'll trust you. Pop it wherever.
Yeah, let's be safe from that. I don't want to break anything. All right, can we do 3B? That work?
Yep. B as in beta.
That's it.
424?
Yeah.
Great. Good job. Amazing. I think this is the emptiest our control van or mission control has been since the start of this expedition. I wonder why that is. I don't think there's anything else important happening right now. Certainly nothing that anybody else would want to watch. Great. Let's go to the red dots. Something else we've been seeing Sorry, pay attention to that. Something else we've been seeing on this expedition a lot of is in all of these areas of seepage, we've been seeing a lot of skates. So we can see one right here. We're just about to fly over, just about to go off the screen on the left. These are deep water relatives of rays and sharks. And we've been seeing so many of them in these seep-like environments, and we aren't sure why. We know in other areas of the deep sea, skates do sometimes use places like hydrothermal vents to lay their eggs in the warm fluid so that that can help to accelerate the development of the eggs because the deep sea is so cold. What is going on here? We are not sure, but certainly a lot of skates around, both males and females. Oh, goal already, apparently. No? Not yet. Hasn't started yet. We've also on this dive been seeing a lot of these shrimp, the white and pink ones. We think they may be perhaps glyphocrangon or some species like that, but there are a lot of them around. Yep. Great. So as I said last night, we did map the seafloor, and we are able, through that mapping process, to actually detect bubbles coming from the seafloor, believe it or not. And those bubbles can usually indicate areas of where seepage is coming out of the seafloor. And often what's happened on this expedition is that seepage tends to be methane and is powering these incredible ecosystems. Oh yeah, I see something.
You see something?
No, I think it's just the edge actually.
So if you just turn.
But it definitely looks like there's an edge. Yeah.
Let the sonar stay. Let's see if there's anything. Maybe kind of past it. She says that's about a 10-meter error on that, so it's a pretty decent sized area.
90 degrees you want?
Yeah, I just basically spin and face it and sweep it with the sonar.
Yeah, do we think those are pock marks in front of us?
Yeah.
Can we just go take a look at them? Yeah.
We've seen a bunch of them on this, in this area. Pock marks, they're like these
Holes, kind of.
fluid flow can
Yeah.
inflate, and then when it comes out, it inflates. Yeah.
Whoa. Wow. I was not thinking it'd be this big. So we're on the sonar, we are seeing these sort of holes, depressions ahead of us. This is one of them, and we can see the evidence of seepage happening. Not a lot, but we do see this reduced blackened sediment. There are dead clams, which would have once indicated that there was seepage here. Interesting. Can we go look at the other one? Is it around? Very interesting. Yes, please. Mm-hmm. So here's another one of these features. And so just for some context, we are climbing the side of what we believe to be a mud volcano. And so these big sort of depressions could be places where methane has come out of the seafloor and then it's kind of collapsed to create these pockmark type environments. This is all just very uneven sediment. Wow, and so we bypassed. So let's, wow, that sonar image is very weird. I'm not sure what to do. What do you think? Oh, I was like, what's happening?
Oh, we're doing an hour. We're doing an hour and an hour, that's all.
What do you think about the sonar, Rachel?
I mean,
And also where we are compared to the red
yeah, I
dots.
can't tell on the in the map. Let me see the. Zoom out so we can see
So while we're trying to work out what to do in relation to the bubble, the potential bubble streams, as well as what we're seeing on the sonar, I'm going to hand you over to our next scientist. You ready? Yeah. Robert Cassidy, who is joining us from Spain, and he will introduce himself. Sponge Rob. Taking all of your things? No, I'm not supposed to. Like a klepto.
Thanks. Red
So
bubble,
we
you
have
think about your wife.
a few things. So we've got some yellow sponges, purple coral,
Yep.
this. And then we did put something into a quiver.
Okay.
Quiver 1, we have a coral.
Okay.
Otherwise everything's free. And then in terms of we're in between waypoints 4 and 5, right in the barrier where the bubbles are supposed to be. And so we're seeing some seepage, but not anything crazy yet.
Okay. Sounds good. Thanks.
Thanks, Rob.
Hey, Rob.
Hey, how you guys doing?
Amazing.
Good.
Are you also amazing?
Yeah, I'm feeling great. Top of the world. Hi everyone, this is Robert Cassidy. I'm a PhD student at the National Museum of Natural Sciences in Madrid, and I'm taking over for Diva. We're continuing our bubble hunt, as always. So we're basically pretty close to the area we expect to find them right now. Just kind of keeping our eyes peeled.
Do you want to head to those red bubbles, or did you want to carry on to the south, or what you want to do?
I think we want to head towards the red bubbles, honestly. Well, let's see, let me get oriented here. Where are they relative to the waypoint?
They're kind of just south of the waypoint. Like,
Okay.
see that?
Yeah.
See that white bar? That's the bottom of the number.
Right. Okay. Yeah, I'd say let's head towards the bubbles for sure then.
Okay, so I could hit all three on the way there. If you want.
That'd be perfect. Yep.
We got something on the sonar.
Yeah. Is that the dive plan right there?
Or did I also take that?
That's okay. Thanks.
There is one that's already annotated, but it's not below the other one.
This is the annotated one. Looks like.
Yeah, that's it.
Thanks. Okay, so we're seeing pretty kind of sloped area here. We've been climbing this mountain for a while now, heading towards waypoint 6, and we're coming pretty close. trying to do kind of a flyby of areas that we have mapped bubbles in. Oh yeah. Mm. Yeah, I guess what we could do is just kind of
Start heading towards the next one.
yeah, maybe I don't know, see what we find on the sonar if anything.
We have a little bit of rocky stuff. You can check that out if you want.
That'd be good. Yeah.
Might have been way
Over here maybe. Or you think we were here already?
Oh. North?
Yeah. Yeah, that'd be good. I don't know, maybe if we kind of veered to the left a bit, we kind of follow these signs of seepage. Yeah.
Here we go.
Got some big corals here.
Left here.
As we've kind of been through this area before, we're just investigating a little bit more.
Now we're in the new, I think we're starting to get into the new stuff here.
Yeah. Okay. Yeah, that'd be good. Do you see some bacterial mats here, it looks like?
Is that different color?
I think so, yeah. Yeah, that's perfect. Okay, so we're heading towards bubble candidate number 2 right now, heading up this mound. Seeing some signs of seepage, some tube worms and corals in this area, but we have yet to find the actual bubble site, so.
Bubble here.
Yep.
Maybe just keep going up this hill on the way to 6th thing.
Yeah, I'd say so. I mean, if we kind of maybe scan around the bubble site a little bit before we head directly to the next one. Yeah, the little loop would be good maybe.
More rocky stuff on the sonar to the north.
Yeah, that'd be good to see.
Bubble. Carry on to the next.
Yeah. Yeah. Yeah, so it looks pretty empty right here. When we're looking for these bubble sites, really what we're looking for first is a change in the faunal community, right? As Ziva was explaining before, you get a community that is very much adapted to the seep environment. That kind of changes the closer you get you get to the actual bubble site. So the fact that we're not seeing much here indicates to me that we're probably a little bit off from our these bubbles that we're looking for. I do see some shells though. It looks like a mussel shell or a clam shell down there that's not alive. So there are some signs, but not what we would expect still from a true seep site.
Update waypoint, thank you.
Yeah. Yeah, definitely seen some interesting craters though. I'm not super well versed in the geology of how these things work, but that could have something to do with these mud volcanoes that we're near. Yeah, there's another, looks like a clamshell down there. Could be the case that the seeps are higher up, which is, we think they're closest to waypoint 6, which is what we're heading towards right now as we climb this mound. So it's possible that there's some of these, maybe shells falling down the slope from a seep site higher up. Okay. So far, the different seep sites that we've explored on this trip, many of which have been totally new for science, we've found a pretty extreme array of diversity. You know, things ranging from giant mussels to tube worms to sponges, and a lot of different amphipods and polychaetes. We've actually started doing some DNA sequencing on board already, and we have some sequences from about 45 species, and from the looks of it, definitely some of them are new. Been also finding a lot of species that have only been recently discovered as well, or potentially close relatives of recently discovered species of some amphipods and polychaetes so far.
Harvey Bridge? Yeah, I'm just bringing the heading around.